is TypeScript? What are we doing here? Well, at the end of the day, I want you to imagine that when we write TypeScript code, we are really just writing JavaScript. That's what's really happening here. We're still writing JavaScript. All the knowledge you have around JavaScript, like arrays, objects, functions, and even ES 2015 syntax like destructuring and arrow functions and classes, all that knowledge still applies to the world of TypeScript as well. The only thing that we're really doing with TypeScript is adding in a little bit additional syntax to our code to handle something called the type system. This is what TypeScript is all about, as you might guess, and it's what we're going to spend the vast majority of this course learning about. So let's get a quick overview on the type system and understand what's going on with it. The goal of the type system is to help us catch errors during development. In other words, when we're actually writing our code in our code editor. Think about how we catch errors right now with JavaScript code. Let's imagine that you're writing out some amount of JavaScript inside of your editor, and maybe there's a bug inside of it. How would you find that bug? Well, really, with JavaScript, the only way to do that is to actually execute your code and see that error appear. And that's not super efficient. So as an improvement to the development workflow, we use the type system to help us catch errors during development. While you and I are writing our code, TypeScript is going to be constantly analyzing it and looking for bugs. If it finds any possible bug, it's then going to pop open an error message inside of your code editor and tell you, hey, something might be wrong here. And that's going to essentially be a signal to you as the developer that you might need to fix up your code. Now, to do this error checking, the TypeScript compiler is going to use something called type annotations to analyze our code base. You and I are going to be responsible for adding in these type annotations. You can kind of think of these type annotations as being like little comments to describe the purpose of our code or the information that is flowing through our program. The type system is only active during development. So in other words, once we go to deploy our application or even run it inside of our browser in a development environment, the entire type system falls away. Your browser has no idea what TypeScript is, and Node.js likewise. Node.js has no idea what TypeScript is either. So all this extra syntax we're going to add into our code never makes it into the browser, it never makes it into Node.js. We're going to first compile our TypeScript, and we're going to get some JavaScript out of that. And that JavaScript is what we're going to actually execute. Finally, this is something I want to point out just because it's a little bit different than other languages that are strongly typed. The TypeScript compiler does not do any performance optimization whatsoever. Now, this is very different than many other languages. In many other languages, the type system can be used to optimize some code that you write using the compiler, but that is not the case here with TypeScript. All right, so to kind of help you understand this process here, let's run through the common scenario of how we're going to actually write some code and run it inside the browser or with Node.js. So you and I are going to write some TypeScript code inside of our editor. And remember, we can think of TypeScript as really just being plain JavaScript, but with these type annotation things added in. Then once we want to actually run our code, we're going to feed that code into the TypeScript compiler. This is a command line tool that's going to read our code, check it for any possible errors, and then convert it into plain JavaScript. You and I are then going to take that JavaScript code and feed it into the browser or into Node.js and finally execute it. So again, we do not execute TypeScript. We always are executing JavaScript. And so when I say that you and I are still writing technically JavaScript code here, it is because the code we're writing, it is going to end up as JavaScript. Just it has these extra little type annotation things in it. All right, so to give you a really practical example of this, I want to show you a quick little web page here. This is a in-browser TypeScript compiler. So I'm going to open up this link inside of a new browser tab. Now on the left-hand side, you're going to see a little bit of TypeScript code. And I know this is kind of cut off right there, but I just want to give you the impression that this TypeScript right here has a bunch of additional syntax in it, right? Just take a look at this code. We don't need to understand what it does. You can tell at just a glance that there's a lot of extra stuff in here, and it does not look like normal JavaScript. So on the left-hand side, we've got the TypeScript. This page is going to compile that code and then print out the equivalent JavaScript on the right-hand side. So this is the output from the TypeScript compiler. And looking at that, yep, it sure looks like plain JavaScript. So I can't say it enough. Like I said, I'm going to repeat it many times throughout this course. We're still writing JavaScript code. we're just adding in little extra pieces of syntax here and there. And these extra pieces of syntax are meant to help the TypeScript compiler understand what we're trying to do with our codebase, so it can help us catch errors. That's it. That's the entire TypeScript world. All right, let's do a quick wrap up on what we learned in this video. So first off, when we write TypeScript, we're still writing JavaScript. We're just adding in these extra little type annotation things. Secondly, TypeScript has no effect on how our code actually gets executed. In other words, there is no performance optimization or anything like that. Now finally, the best way to think of TypeScript, in my opinion, or kind of an effective analogy, is to think of TypeScript as being like a friend who is sitting behind you while you are writing code. And maybe that friend is looking at every line of code you're writing and helping you catch errors. That's what TypeScript is really doing for us. It is a helper to help us catch errors. It doesn't actually have any impact on the final code that we output or the actual code that we run inside the browser. It's just there during development. Okay, so now we've got a better idea of TypeScript. Let's take a quick pause right here, and we're going to do a little bit of environment setup in the next video. In this video, we're going to do a little bit of environment setup. Once we set up our local machine to work with TypeScript, we'll then begin working on our first project. So let's get to it. The first thing we'll do is to install the TypeScript compiler. To install it, we're going to use npm. Now, if you're here in this course, I'm going to assume that you've got a basic understanding of both Node and npm. So I'm going to assume, in particular, that you've already got Node and npm installed on your local system. If you don't, you'll want to do a quick Google search on how to install Node on your local machine. Again, I'm really assuming that you've got that knowledge ahead of time. So we're going to use npm to install TypeScript as a global module. We're also going to install a second module called tsnode. tsnode is a little command line tool that allows us to compile and execute TypeScript with one command at our terminal. We're going to use it in the first half of this course just for running some TypeScript very quickly without having to set up a full tooling installation kind of deal. So let's get to it. I'm going to open up my terminal. Once over here, I'm going to run npm install -g, and I'll get TypeScript and ts-node like so. All right, so that's going to take just a moment or two to install rather quickly. Once it is installed, I can then make sure that it is successfully installed, and then I can run the compiler by running tsc --help, like so. So we installed a package called TypeScript. It gives us access to a command called tsc, which is short for, as you might guess, TypeScript compiler. This is what we're going to use to actually compile our TypeScript code into plain JavaScript. So if I run this command, I should see a bunch of help messages appear on the screen like so. If you see any error, that means that your npm installation probably has a little issue and you'll need to do a little bit of troubleshooting. Okay, so that's pretty much it for the actual TypeScript setup. Now we're going to walk through a little additional setup here for setting up Visual Studio Code. Now this is a code editor. If you've already got Visual Studio Code installed, I encourage you to still watch this video because I'm going to show you some settings that are important for you to have. If you want to use another code editor inside this course, that's totally fine. I've tried out many other code editors, and personally, I think that Visual Studio Code is one of the best ones out there for working with TypeScript. So if you've never used it, I would recommend at least try it one time. So I'm going to go through the installation process here really quickly. I'll first go to that link inside of a new browser tab, and I'll find the green download button on the left-hand side. Once I download this zip file, I'll then open it up. That's going to extract it. Here's the Visual Studio Code application. And if you're on Mac, all you have to do is drag and drop that into the applications folder. If you're on Windows, you're going to instead see a little installer. All you have to do is go through the installation process. It's just a couple clicks. Now that we've got VS Code installed, we're going to do just a couple steps of configuration. So this is what we're going to go through. I'm mostly showing you these configuration steps just so you understand the exact settings that I'm running locally. Now, just to be clear, I just did a fresh installation of VS Code, like I completely deleted my previous installation. So when I go through these settings, you're going to see a fresh installation being set up here. So I don't have any previous setup whatsoever. All right, so let's get to it. The first thing I'm going to do is open up Visual Studio Code. And it's going to take just a moment this first time that it boots up to actually open. So I'm just going to let it do its thing. All right, there we go. All right, so once I've got Visual Studio Code open, we're going to go through each of these different setup steps right here. So the first thing I'm going to do is set up code in my path variable. Now what this essentially does is allow me to launch my code editor from the terminal, which I'm going to be doing quite a bit throughout this course. So to do so, I'm going to go over to the editor, and then I'll go up to View, and then find Command Palette. And then once here, I'm going to search for Add Path. Actually, not Add Path. I think it's Install Path. Yeah, there we go. So install code command in path. All we have to do is click that, and that's pretty much it. We'll see a little notification down here. If I now flip on over to my terminal, I can open up a new window. Make sure you open up a new window. If you try to run this command in an existing window, it's probably going to fail. And then once over here, you can open up your code editor in any directory by running code and then dot, like so. And as you'll see, it'll pop open my code editor right away. All right, so let's keep going through these installation steps. The other ones are going to be pretty quick. So the next one is going to be to install the Prettier extension. Prettier is a code formatter. It's going to take a look at your code every time you save a file and automatically format it in some fixed fashion. So I usually use Prettier just to have some very consistent looking code, and I highly recommend you try it out as well. To install this extension, I'll go back over to my editor. I'll find View. I'll then look for Extensions. And then on the left-hand side, I'll search for Prettier. And it's going to be the first one right here by Esben Peterson. So I'll hit install. And that's pretty much it. Now we're going to do a little bit of configuration on Prettier. We're going to make sure first that it formats every file when we save it. So to do so, I'll go back over. I'm going to again go to my View menu. And then I'm going to look for, not View, I'm looking for Preferences, or excuse me, Code Preferences Settings. There it is. And then once I've got the Settings tab up right here, I'll do a search for Format on Save. And I'll see a setting right here called Format on Save. So we just have to check that, and that's pretty much it. Next up, I'm going to configure Prettier to use single quotes. Now this is entirely personal. If you want to use double quotes, totally fine. You can use either single quotes or double quotes safely with TypeScript. I just prefer single quotes. So to set up Prettier to format my code in that fashion, I'll go back over to my settings page. I'll look for single quotes, and I'll scroll down just a little bit right here, and I'll see a setting called Prettier single quote, and check it. All right, next one is I'm going to make sure that I use 2 spaces for indentation as opposed to tabs. Again, this is very personal. You can go either way. I personally like to use 2 spaces for indentation. So to do so, I'm going to delete the search term up here, and then scroll down on the default settings here just a little bit, and I should see tab size right here, and I'll just change it to 2, like so. All right, so last thing, I'm going to set my theme to be solarized light. So that's just going to change the coloring of my editor a little bit. So to do so, I'm going to go back over once again. I'll look for theme. I'll find color theme right here. Right now the default is dark, and I'm going to change it to solarized light instead. And that's it. Okay, now one last little thing I'm going to do here. I am going to hide this bar on the left-hand side. I can find that setting by looking up activity bar. So workbench, activity bar visible, and I'm just going to deselect that so that little bar on the side goes away. All right, so that's it. That's all the configuration I do to my editor. So if you went through these steps, you now have an editor that's set up identically to mine. So now that we've got everything set up for our local environment, let's take a quick pause right here, and we're going to start writing some code in the next video. In the last video, we did a little bit of environment setup, and now we're ready to start working on our first project. So let's talk about what we're going to make. All right, so we're going to start off with a very simple first little application. We're going to make a little tiny application that's just going to make a network request to some outside API, fetch some data, and then we're going to try to print that data inside of our terminal. And that's it. Now with this first application, I'm not trying to teach you any specific syntax or anything like that. I just want to show you why we use TypeScript in general. So as we write this program, we're going to accidentally, quote unquote, kind of accidentally, introduce 1 or 2 bugs into our application. And then we're going to very quickly see that TypeScript has the ability to help us catch those bugs while we are writing our code, as opposed to when we execute our code. So again, the point of this application is just to show you the typical workflow of TypeScript. That's it. All right, so with that in mind, let's talk about the flow that we're going to go through to actually build this application. So step one, we're going to take a look at the API that we're going to use to fetch some data. After that, we're going to create a new project directory. We're going to create a package.json file inside there, and then install Axios as an NPM module. Axios is a little module that we're going to use just to make a network request. If you've never worked with this module before, totally fine. Axios doesn't really have anything to do with TypeScript. We're just going to use it to make a network request. That's it. So once we do all that setup, then we'll start to write out some code. All right, so on to step number one. Let's take a look at the API that we're going to use to fetch some data. So here's a link to the API right here on the screen. Now this is a fake API. In other words, it serves up fake data that we can use just for like testing or learning purposes. In other words, it's perfect for what we are trying to do right now. So I'm going to pull up that documentation inside of a new tab, and then scroll on down to a section called Resources. All right, so here's Resources right here. So these are all the different types of records that we can make a request to or attempt to fetch from this API. We're going to attempt to fetch this list of to-dos right here. So I'm going to click on that /to-dos link. As soon as I do so, you're going to see a ton of information appear on the screen. You'll notice that on my screen, it appears to be very nicely formatted. If it looks like a big blob of text on your screen, that's totally fine. I've got a little Chrome extension to automatically format JSON data for me. So if we make a network request to this URL right here, we're going to get back a big list of fake to-do items. Now we don't really need this whole list. I just want to try to fetch like one individual item. So to fetch just this first item off the list, or the to-do with an ID of 1, we can modify the URL up here slightly. So at the very end of the URL, I'll add on /1, like so. Once I visit that link, I'll then see a single to-do appear on the screen. So this is the exact data that we want to fetch. I want to fetch this data inside of our application, and then just try to print out some information from this to-do to our terminal. Like I said, that's it. All right, so now that we understand the API we're going to work with, we'll now flip on over to our terminal and create a new project directory. So over inside of my terminal, I'm inside of a workspace directory of sorts. You can place this folder anywhere on your machine that you want to. I'll make a new project folder inside of here, and I'm going to call it fetch.json. I'll then change into that directory, and then I'm going to generate a new package.json file inside of here. Remember, package.json files are used to record all the different dependencies that we install into a project. Normally that's the case for JavaScript projects, but it's the same thing for TypeScript as well. We record dependencies inside of a package.json file. So to generate that file, I'll run npm init-y. That's going to generate that file, and now I can safely install that Axios module. Remember, Axios is going to be used just to make that network request. So to do so, I'll run npm install Axios, like so. Now Axios is really small, so this should install rather quickly. Once it's all done, I'll then open up my code editor inside this folder, and we'll start to work on our project. All right, so here we go. I should see inside of here the package.json file and the node modules directory, which has that Axios project or module that we just installed. So now that we've got everything set up, let's take a quick pause right here, and we'll start to write some code in the next video. Now that we've got our project all set up and ready to go, we can start to actually write out some code. So to get started, I'm going to create a new file inside my project directory called index.ts. Notice the file extension on here is .ts. That's short for, as you might guess, TypeScript. We're always going to place all of our TypeScript code into .ts files. So now inside this file, we can start to actually write out some code to implement our program. And just as a quick reminder, our goal here is to fetch some JSON data and print the result. For this first program, we're going to speed through the implementation very quickly. It's not going to have a lot of TypeScript-specific syntax in it just yet. Remember, the goal of this first application is not to learn a bunch of different TypeScript syntax. Instead, I just want to show you why TypeScript is handy. So to get started, we're going to first import that Axios module that we just installed. At the top of the file, I will write out import Axios from Axios like so. After that, I'm going to flip back over to my browser, go to that JSON placeholder endpoint right here, and copy the URL that's going to give me just the first to do. So I'll copy that URL, then go back over to my editor. I'm going to create a variable called URL and assign that URL to it, like so. So now that we've got the URL in here, we can use Axios to make a network request to this URL. To do so, I'll write out axios.get, and then I'll pass in that URL. So that's going to make a HTTP GET request to that URL and attempt to fetch that JSON data. That entire operation is async, so by calling axios.get, we're going to receive a promise in return. So to get a notification on when the request is complete, we can chain on a .then statement that will be called with the response once we get a response from that API. So then inside of here, remember the goal here was to just console log out the JSON data we get back. So I'm going to console log response.data, which should be the actual to-do that we receive back from that API. All right, so let's save this. That's the entire program right here. We are going to make a couple changes to it in just a moment, but let's just try to figure out how to run this code now. Remember, we cannot run TypeScript code directly inside the browser or with Node.js. We have to first compile this file into plain JavaScript, and then we can execute the resulting JavaScript code. So to compile this file right here, we will flip back over to our terminal. Inside of my terminal, I'm going to use the TypeScript compiler that we just installed 2 videos ago. We can access that compiler by writing out TSC. Remember, that stands for TypeScript compiler. And then I'll feed in the name of the file that I want to compile. I'll run that command, and then I'll get kicked back over to my terminal almost instantly. So it seems like nothing happened, but the compilation did occur. If you flip back over to your code editor and look at the file explorer on the left-hand side, you'll see that we've got a new file inside of here called index.js. So that is the compiled version of our TypeScript code. You can open up that file, and you'll see what TypeScript did to our code base. All right, so now to run this, we can use the node command line tool, and we'll run node index.js, and that will execute the compiled JavaScript file that we just created. So back at my terminal, I'll run node index.js. Notice the extension on here, we are running the JavaScript file. So if I run that command, I'll then see the to-do printed out on the screen. Perfect. All right, so as you might guess, having to always run tsc index.ts and then compile, and then run that resulting file gets really old really quickly. So to combine these 2 commands into just one, we also installed a little module 2 videos ago called ts-node. ts-node is going to combine these 2 commands into one. So it's going to automatically compile a given file and then automatically execute the resulting JavaScript. So it's just saving us from having to run that one extra command. So we can run ts-node and then the name of the TypeScript file that we want to execute. So index.ts. So I'll then run that command. And then I should see my JSON printed out. Yep, there we go. A little bit of a pause there. I guess my internet connection is a little bit spotty right now, but I saw the printout right there. So in one step, we compiled and then executed the resulting JavaScript. Okay, so that's how we put together a very basic TypeScript program and then execute it at the terminal. But I still haven't really shown you anything around, why TypeScript is handy here. So let's take a quick pause, and when we come back in the next video, we're going to start making a couple changes to this program, and then we'll very quickly see why making use of TypeScript is really, really handy. So quick pause, and I'll see you in just a minute. In the last video, we were able to write out some code to fetch a single to-do and print it out at the terminal. Now everything works pretty well, but this console log right here is kind of ugly and it's hard to understand in this kind of object format. So in this video, I want to pull off the ID, title, and completed flags and print them out in a nicer format, kind of like a little report of sorts. So let's try making some changes to our code base. I'm going to flip back over to my editor, and to get started, I'm going to first get a direct reference to the to-do, which is that data property right there. So I'm going to essentially pull off that data property and assign it to a separate variable, again, just to make it easier to work with. So I'll say const to-do is response.data. So now that we've got the to-do, we can pull off the ID, the title, and completed properties. I'll assign them to some temporary variables, And then we can insert them all into a single string and console log that string to essentially put together our report. So I'm going to pull off those three properties that we just took a look at. So I'll say const ID is todo.id. I'll get title as todo.title. And I'll say finished is todo.finished, like so. Now, if you're looking at these three lines of code and thinking, hey, Steven, you just messed something up right here, that's totally fine. Just bear with me for a second. If you're looking at this code and you don't see anything wrong, that's totally fine as well. Again, just bear with me for a moment. So now underneath that, we can start to print out a nice little report here. So I'll do a console log. To print out this as a nice little report, I want to use a multi-line string that is capable of using string templating. So I want to kind of inject some variables into the string. To do so, we can use a template string, just as you might be familiar with from ES 2015. So inside of here, I'm going to put a set of backticks. Remember, these are backticks. It's the character to the left of the 1 on your keyboard. They are not single quotes. I'm going to turn this into a multi-line string. And I'll say something like the to-do with ID, a colon, and then I'll print out the ID. And I'll just like print out the title underneath. I'll say has a title of $title. And I'll print out whether or not it is finished. So I'll say something like, is it finished? And I'll print in the finished variable, like so. All right, so that's a little bit nicer to read report right there than the plain console log that we had before. So let's save this file and then attempt to run it at our terminal. So I'm going to flip back over to my terminal, and I'll run the file in one step using tsnode once again. So I'll say tsnode index.ts. Remember, we are feeding in the TypeScript file here. We're not making use of the plain JavaScript file anymore. So I'll run this command, and sure enough, I end up seeing undefined, undefined, undefined. Well, what's up with that? That's kind of unexpected. We just saw all that data appear correctly a moment ago when we did the console log. So that means that we must have made a mistake somewhere in here. So what is going wrong? Well, let's take a quick pause right here. When we come back in the next video, we're going to make sure it's really clear what's wrong with this program, and then we're going to start to discuss how we can easily use TypeScript to avoid making the error that we just made inside of here. So quick pause, and I'll see you in just a minute. In the last video, we updated our program, so we print out a nice report about a single to-do. However, when we then ran that program, we saw 3 undefineds inside of our terminal. So let's figure out what's going wrong. I want you to take a look at these 3 variable declarations right here. In every case, we tried to pull some property off of that to-do object. So we tried to pull off the property capital ID, capital T title, and finished. So that's where we made our mistakes. Take a look at those property names right there. And then I'm going to flip back over to my browser and take a look at the actual property names that belong to that title, or excuse me, that to-do object. The actual property names are lowercase ID, lowercase title, and it's not finished, it's completed. So what's the lesson here? Well, the lesson is we wrote out some code that had a very nasty bug inside of it. But we were not made aware of that bug. We didn't even know it existed until we actually executed our program. So this right here is exactly what TypeScript is made to prevent. TypeScript is going to help us catch errors like these simple typos we just made right here while we are still writing code inside of our code editor, as opposed to when we actually execute our code. So let's start to now make a couple changes to this file. We're going to add in a little bit of basic TypeScript syntax that's going to help us very easily catch the errors that we just made. Now remember, as we start to write out this TypeScript stuff, we're not really focused on TypeScript just yet. So like the syntax, don't worry about it too much just yet. We're going to go over all the syntax in great detail over time. For right now, I just want you to see how TypeScript can help us fix the errors that we just made. So I want to focus on this response.data object right here. You know what would have been really nice? It would have been great if we had a comment somewhere in here, like maybe right above. Maybe if we had a comment that said response.data has properties of, and then we just like listed the property names out and said like ID and title and completed. If we had some comment like this right here, then it probably would have been way less likely that we would have made those typos, because we would have seen some information about that data object or the to-do right there on the screen right above. So this comment right here is essentially what we're going to add in, but in TypeScript form. So I'm going to delete that comment. And right above my Axios call, I'm going to write out our first little bit of TypeScript. So I'm going to say interface to do. I'm going to put down a set of curly braces, and then I'm going to write out the 3 different properties that the to-do has. And I'm going to also label the type of data that each of those properties reference. So I'm going to say ID is a number, and I'll put a semicolon at the end of the line. I'll say title, a colon, and then string and a semicolon, and then completed, which was a Boolean, like so. All right, so this is, like I said, our first little bit of TypeScript. This defines something called an interface. Interfaces in TypeScript are used to define the structure of an object. So as you might guess, we are saying that inside of our application, there's going to be some kind of object called a to-do. And every to-do is going to have 3 distinct properties. It's going to have one property called ID, it's going to have a title, and it's going to have a completed property as well. The ID is going to be a number, title is going to be a string, and completed is going to be a Boolean, so either true or false. I did not make these property names up, or excuse me, these types right here up on the fly. If you actually go back over to that JSON printout right here, you'll see that ID was in fact a number, title was a string, and completed was a Boolean. So I created that interface to tell TypeScript about what type of information we're going to expect to receive back from this API. Now you'll notice that at this point in time, I'm completely ignoring this user ID property, and that's totally fine. Inside of an interface, we can freely ignore properties if we want to. We'll go into more detail on that later on. So now that I've told TypeScript about this type of object that's going to exist inside of my application, I'm going to now go ahead and tell TypeScript that this response.data thing right here is going to be one of those to-dos. So right after response.data, I'm going to say as to-do, like so. And then as soon as I do so, I'm going to get 3 errors right here light up inside of my editor. So this right here, this is what it is all about. TypeScript has analyzed our code using the type annotations or type labeling that we've added into this program. And it has found that we might have a possible error. So it has now underlined these 3 properties to tell us, hey, developer, you might be doing something wrong here. You need to take a look at this and figure out if this is correct or incorrect. So in this case, we would hover over each of these little errors, and we'll see a little message right here that tells us that exactly what might be going wrong. So in this case, it says property ID does not exist on a to-do. Did you mean lowercase ID? And that right there, that is the perfect amount of help that we need to somehow fix up this code. So instead of capital ID, I'll change that to lowercase ID, and then that error message goes away. Now, just to be totally complete, I'm going to also change the name of the variable to lowercase ID as well, just to be consistent. And I'll update the console log down here to lowercase ID as well. So now we would repeat the same process with title. I'll mouse over, and it says, did you mean lowercase t title? Well, in fact, yep, I did. And then finally with finished, I'll mouse over, and in this case, it just says, hey, that property just does not exist here. You probably meant to reference something else. And so once again, this would be my signal as a developer that I probably did something wrong here and I need to fix this up. So I could go and take a look at my definition of what a to-do is once again, and I'll see, oh, the property name is completed, not finished. And so I'd go back down and update this to be completed. And once again, I'll change the variable name as well, even though technically I don't have to. And completed down here as well. All right, so now if we save this program again, we can flip back over to our terminal and attempt to run this once more. So I'll do a ts node index.ts. And then once I do so, I'll see the correct output at my console. All right, perfect. So what's the lesson here? Well, like I've said several times so far, the goal of TypeScript is to help us catch errors during development. Notice how we didn't see an error during the compilation phase. We didn't see an error with our program when we actually ran our code. We saw an error as soon as we defined this interface thing and then told TypeScript that this object right here was going to have the same structure as what is described by a to-do. As soon as we added that in, we got some feedback while we were writing our code. And that was the key. That was the signal to you and I as a developer that we had to fix something up. And once again, that is what TypeScript is all about. All right, so now that we've got a little fix in here and everything's looking a lot better, I want to make one more change to this program. So let's take a quick pause right here and we'll continue in the next video. In this video, I want to make one additional change to our program. I want to take this console log statement and extract it into a separate helper function. So that will allow us to leave this promise body right here a little bit more compact than it currently is. So to get started, I'm going to define a new function at the bottom of the file. I'm going to call it log to do. I'm going to set this up as an arrow function, and I'm going to say that when we call this function, we should take in the arguments ID, title, and completed. Now, if you see a little nasty underline right here, like a yellow or even a red underline, that's totally fine. Just stick with it for a moment. Once I define that function, I'm then going to cut and paste the console log inside there, like so. So now we can call that function from up here, and that will do our console log for us. So I'm going to call log to do, and I'll pass in the ID, that completed flag, and the title like so. Now, once again, if you're looking at this and you're thinking, Steven, you just made an error there, that's totally fine. Once again, just bear with me for a moment. So I'm not going to save this file, and I'm going to flip back over to my terminal, and let's try to run this once more. So I'll do a ts node index.ts, and my program runs, but if you look carefully, the console log is not quite right. So it says, has a title of false. Is it finished? Delectus aut autumn? Something's definitely off here. So what did we do wrong? Well, if I flip back over and look very carefully, you'll notice on my log to do function, I was expecting arguments in the order of ID, and then the title, and then completed. However, when I called the function, I passed in ID, then completed, and then title. So I clearly mixed up the order of arguments into the function. And once again, I got absolutely no information about the error that I just made until I actually executed my code at the terminal. So once again, here's the lesson about TypeScript. If we're not using TypeScript correctly, or if we're just writing out plain JavaScript, we don't find errors until we run our code, which is pretty inefficient from a developer perspective. So if we used TypeScript appropriately, we could have gotten a warning about this or some error inside of our editor before we ran our code, and that would have been a signal to you and me that we had to fix up something. So how are we going to fix this up? Well, I'm going to find my log to do function right here, and on each of these arguments, I'm going to add in a type annotation. So we've used that term several times so far. Remember, we're going to really clarify all these TypeScript topics in just a moment. So for right now, just bear with me. We're going to add in a little bit of TypeScript syntax here. So I'm going to say that this ID variable, whatever we pass in here, it has to be a number. And then our title, it has to be a string. Remember, that makes sense. Our title is going to be a string. And that completed flag, it has to be a Boolean, either true or false. So we've now written out ID, number, and then the same thing for the other two arguments as well. Now this is not creating an object or anything like that. Instead, we are trying to describe the type of variable that ID is going to be, the type of variable that title is going to be, and the same thing for completed as well. Now, as soon as I add that in, I can then see a red underline under the completed flag right here. And if I hover over it, it will tell me argument of type Boolean is not assignable to parameter of type string. So what this is telling me is that completed is supposed to be a Boolean, right? That's what this is. Completed is a Boolean. It is a true or false value. And I tried to pass it in as the second argument to the log to do function. But log to do says the second argument has to be a string. A Boolean is not a string, and that's why we are seeing this error. So once again, this is a notice to you and I as developers that we're doing something incorrectly and we have to fix this up. So in this case, I would probably analyze this and say, oh, yeah, I just made a mistake in the order of arguments here. So I would flip the order around, like so, and then the error message goes away. And now I can save this file. I can flip back over to my terminal again, run the file once more, and now I'll see the correct result. All right, so that's it. 2 quick examples of why we like to use TypeScript. We just saw 2 examples of extremely common errors, like people making typos on object properties that happens every day, probably thousands or even tens of thousands of times a day across the world with JavaScript. And we also saw an example of calling a function with the incorrect order of arguments. Also an extremely common error. In both cases, we would have had to run our code to find these errors. But by using a tiny amount of TypeScript, we found these errors during development and we saved ourselves a lot of time. So we've now seen some very basic examples of why we like to use TypeScript. So let's take a quick pause right here. We're going to start working on our next application in the next video. In this video, we're going to start to cover our first big topic, which is basic types in TypeScript. For every topic that we go through, here's the game plan we're going to try to follow. First off, we're going to get a plain definition and overview of the subject. We're then going to talk about why we care about each feature. In some cases, we're going to discuss features in TypeScript that I really don't think you're going to use that often. And so I want to kind of make that clear. I want you to understand, why do we care about these features and how often will you actually use them? After that, we'll then take a look at some different examples inside of our code editor by actually writing out some code. And then finally, we'll close every topic out with a discussion of when to use it. Sometimes when to use it is going to be a little bit quick, and it will really be in some of the applications we put together that you're going to discover when we use some of these different features. Okay, so that's the flow we're going to go through. Like I said, our first topic is going to be basic types, so let's get to it. Let's begin with a plain definition, or as plain as I can make it. Now, I'm sure if you open up a dictionary, you're going to find a very academic definition of what a type is, but if I had to use my own words to describe what a type is, here's what I would say. I would say that in TypeScript, a type is an easy way to refer to the different properties and functions that a value has. And there's a lot of meaning in this statement right here, so let's kind of break it apart piece by piece. First off, what is a value? Well, a value in JavaScript and TypeScript is anything that we can assign to a variable. So what can we assign to variables? Well, we can assign strings, numbers, booleans, null, undefined, objects, functions, classes, arrays, and so on. So all of those different things have types. An array has a type. An object has a type. A function has a type. A class has a type, and so on. So let's now break down the first part of the statement. What do I mean by an easy way to refer to the different properties and functions? Well, to answer that, maybe it would be easier to take a look at a quick diagram. All right, so in this diagram right here, I want you to take a look at this box right here, and I want you to answer a question for me. Here's the question. What is inside that box? What is in there? I think you can probably give me two answers. Maybe one would be to simply say it is a string. Alternatively, if you wanted to give me a more detailed answer, you might say it is a value that has all the properties and methods that we assume that a string has. So to really understand that part, I think we would really need to understand what different properties and methods a string has. Here's a short list of just some of the functions that belong to a string in JavaScript. So every string in JavaScript has access to the character at function, and concat, and includes, and index of, and so on. If I had to tell you what this thing is right here by listing out all the different functions that belong to it, that would be really inconvenient. In other words, if I asked you what is inside this box and you responded to me, oh yeah, Steven, that is a value that has the function character at, and concat, and includes, and index of, and so on, that would be super inconvenient. So instead, as a shortcut to describe what properties and function this thing has, you summarize it in a single word. You tell me this is a string. So when we refer to the type of a value, it is a shortcut to refer to the different methods and properties that that value has. Every value that we create has a type assigned to it. In some cases, that type is going to be really obvious, like in the case of this string right here. However, in some other cases, we're going to learn that types exist that are tied to values that you kind of wouldn't expect. So for example, let's take a quick glance at that application we just worked on a moment ago. Remember, inside of here, we created an interface called to-do. When we created this interface, we created a new type inside of our application, and that type's name was to-do. So there are two ways that I could have referred to this response.data thing right here. I could have either told you, oh yes, response.data is an object that has an ID property, a title property, and a completed property. But if I had to repeat that statement every single time you asked me what this variable was, it would be just really inconvenient. So instead, we formed a shortcut. Instead, I can say response.data is a to-do, and instantly you understand what response.data is. It is an object that has an ID, title, and completed property. Okay, so to sum up here, the big takeaway is that when we start to discuss types in TypeScript, these are just shortcuts. They are labels for describing the different properties and methods that a single value has. And then the secondary statement to that is that every value in TypeScript has a type, every single one of them. Okay, so let's take a quick pause right here. We're going to come back in the next video and start to expand on types just a little bit more. Now that we've got a better understanding of what a type is, let's dive a little bit deeper into the subject and then discuss why we care about types at all. All right, so first off, a couple examples of some very basic types. So anytime that we are working with a value that has a type of string, we would expect to see a value that look like these right here. So if I have a value that looks like hi there, that is a string. If I see a value that looks like a string with no characters, that is also a string. And something that says today is Monday, yep, that's a string as well. Likewise, if I've got some really small decimal number, that's a number. A negative number is a number, and a really large number is a number as well. Now, the reason I break out number right here is that in some other languages, there are actually subtypes of numbers. So for example, in other languages, you might have a type to represent numbers that have a decimal, or you might have another type to represent a number that is only an integer and therefore doesn't have a decimal. In JavaScript, or excuse me, in TypeScript, we have nothing like that. A number is a number regardless of whether it is positive, negative, has a decimal, doesn't have a decimal, they're all numbers. If we have a value of true or false, we would say that its type is Boolean. And then remember, we are not only restricted to these basic types right here. Every value in TypeScript has a type. So for example, if we made a new date object, the resulting object from that would have a type of date. And then if we had an object that had an ID, a completed flag, a title flag, we would say that that is an object that has type to do. And this one only applies if we were working in a code base that had defined this interface right here. Remember, this interface defined a new type. Okay, so now that we've seen some examples of different types, let's talk about how all these types kind of relate to each other. So in the world of TypeScript, we have two different categories of types. We have primitive types and object types. Primitive types are all the very basic types that you might guess. So like numbers, strings, Boolean, null, undefined, and then symbol and void are two others we'll talk about later on. The other category we have access to are something called object types. And these are essentially any types that you and I create or any other types that are built into the language itself. So for example, all the different functions that you and I create are going to have their own type. And those are an object type. Any class you and I create is going to have its own type. Same thing with arrays and objects as well. Now, why is there the divide here? Like, why are there two categories, one called primitive types and one called object types? Well, the true answer to this we won't quite see until later on, but just as a quick preview, we say that there's a separate category called object types right here, essentially because you and I can write some code that will essentially trick TypeScript into believing that one value is a different type. I know that sounds really confusing right now, but essentially we can kind of sometimes trick the TypeScript compiler in a very good way. We can do that with object types only. We cannot do that with primitive types. So that's why we have these two separate categories. Again, I know that's confusing to hear right now. I just want you to understand why you will sometimes see these broken out into the two separate categories. Okay, so now that we understand a little bit more about types, on to the last big question here. Why do we care about types at all? If I had to answer that, I would say that there are two big reasons. The first one is that types are used by the TypeScript compiler to analyze our code for errors. So think about the definition that we just gave for types. We just said that types are an easy way to refer to the different properties and functions that a value has. Okay, just keep that in mind for a second. While you keep that in mind, I'm going to flip back over my code editor and take a look at the code that we just wrote a little bit ago. So inside of here, we defined a new type. We said that we had a new type inside of our application called to-do. And a to-do is only ever going to have the properties ID, title, and completed. Then down here on line 12, we said that the variable to-do was going to refer to an object of type to-do. So that means that the object that this variable refers to is only ever going to have these properties. The TypeScript compiler can use that information. So if we start to refer to some property on that to-do variable that doesn't exist, TypeScript is going to throw an error at us. TypeScript knows that this variable refers to an object that has these properties and nothing else. So if we try to reference some other property, there must be something wrong with our code, and TypeScript can discover that and tell us that in the form of an error. So that's why we generally care about types. The other big reason that we care about types, back over here, one more, is that it allows other engineers to understand what values are flowing around in our code base. If you've ever worked on a large JavaScript project before, you might have ran into the scenario where you open up some file and you see some function in there with some really unclear argument name, like maybe a function with an argument name of like the letter A and nothing else. In that case, on a large project, it might be really hard for you to understand what that function is doing. If we instead try to annotate the type of arguments being passed into a function by labeling the types, then that at least gives other engineers some idea of what type of data is flowing around inside of our application. And ultimately, it will make it slightly easier for other engineers to understand what our code is doing. So that's why we care about types. Let's now take a quick pause right here. When we come back in the next video, we're going to start to take a look at some more code snippets to understand what's really going on. So quick pause, and I'll see you in just a minute. In this video, we're going to write out just a little bit of code to get a better idea of what's going on with these types. Now, this first little bit of code that we're going to write around types is going to be really simple and straightforward, just to kind of hammer home some of the concepts we've been talking about. But on some of the other examples or other topics we're going to discuss very shortly, we're going to write out much more complete code snippets. So anyways, let's get started. I'm going to begin by flipping on over to my code editor. I'm still inside of my fetch.json directory. I'm going to change out into my workspace folder. And then inside of here, I'm going to make a new project directory to hold all these different code snippets we're going to put together as we're going through some basic features of TypeScript. So I'm going to make a new directory here called features. I'll then change into that directory, and then I'll open up my code editor inside there. Once my editor is open, I'm then going to make a new file, and I'm just going to call it types.ts. So like I said, I just want to write out one or two quick snippets of code just to get a better idea of what's going on. So I want you to remember that the entire idea behind this type system is that it is an easy way for us to refer to the different properties and functions that a value has. In addition, every value, everything that we can assign to a variable has a type. So to get started, I'm going to flip back over to my code editor, and I want to just try creating a variable that's going to point to an instance of a date object. So I'll say const today is going to be new date, like so. If I hover over that variable, my editor will then tell me the type of value that this variable is pointing at. So this is saying that the today variable is pointing at an object of type date. TypeScript can now use that information to decide exactly what we can do with that variable. So for example, if I put down today and then a dot, I see my autocomplete pop up right here. This is listing out all the different functions and properties that a date object has. TypeScript only knows to show this information right here because it has an internal definition of exactly what a date is. In other words, TypeScript knows the properties and methods that a date has, so it can print them up in this list right here. And I can easily select one and call it like so. And then as we saw just a moment ago, because TypeScript knows what methods a date has and what properties it has, if we try to reference one that doesn't exist, we will very quickly get an error message. So that's the whole point of types. It is a shortcut to say, here are the different properties and methods that this value right here has. Okay, so that's an example of looking at the type that a date object brings up. Let's now try creating a plain JavaScript object. So I'll say something like const person is going to be an object like so, and I'll give this person, how about like just an age of 20. If I now hover over that person variable, I'll see a person, or const person, excuse me, and then right after that, in this case, I don't get a nice name for the type because I've not actually given this object right here a name, a shortened name. So we can kind of see our definition that of a type kind of holds up here. If we don't have a shortened definition of what this object is, then TypeScript is just going to default to printing out all the different properties and methods that the object has. So in this case, it has just an age that is a number. And once again, if we try to reference some property on that variable that doesn't actually exist, we're going to get an error message. Okay, just one more quick example here. So down here, I'm going to try to create a class. I'll call it color. I'm not going to give it any implementation. Now, even if you don't know what a class is, that's totally fine. We're going to go into great detail on classes later on. I can now use this class to make a new instance of a color. So I'll say const red is new color like so. And now, just as we've seen twice before now, if I hover over red, TypeScript knows that this variable is pointing at an object that is of type color. That means that this variable right here has access to all the properties and all the methods that a color object has. In this case, none, because we haven't actually implemented anything here. And we can see that if we write out a red and then dot like so. There are no properties associated with this class of color, so we don't get any autocomplete whatsoever. And if I try to reference anything, as usual, I'll get a very quick error message here as well. Okay, so that's just a couple quick examples of types. So let's take a quick pause right here. We're going to wrap up this idea of types with a quick discussion, really quick, I promise, on where we're going to use types in a normal project. So quick pause, and I'll see you in just a minute. We've now gotten a definition of types. We've spoken about why we care about them, and we just looked at a couple quick examples. So now the last thing we're going to cover is when to use them. All right, so this one's kind of an easy one in this case. And some of the other topics we're going to look at, well, there's going to be a lot better answer of where we use them. But in the case of types, well, we use them everywhere. And that's just a side effect of using TypeScript. So whether you want to or not, every value you define inside your application is going to have a type associated with it. And TypeScript is going to do its best to check the quality of your code or check for any errors by using those types. So like I said, for this particular feature, well, types are used everywhere, and there's really not that much else to say about it. All right, so let's take a quick pause right here. This is kind of a gimme. Let's take a pause right here, and we're going to move on to our next feature in the next video. In this video, we're going to move on to our next big subject, which is type annotations and type inference. These are technically two different systems inside of TypeScript, but we're going to talk about them in parallel for a very good reason. Just to make things a little bit more complicated as well, these two different features apply slightly differently to variable declarations, functions, and objects. So we're going to first talk about type annotations and inference as applied to variables. Then we'll take a break and talk about them applied to functions and then objects and so on. For each of these different subjects, we're going to once again go through some plain definition and overview. We'll then take a look at some different code examples that we're going to write out together. You'll notice I swapped these two steps right here this time around. So we'll then talk about why we care about this annotation and inference stuff, and then we'll discuss when to use it. So let's get to it. First off, some plain definitions. So type annotations, what is that? A type annotation is some tiny bit of code that you and I are going to write to tell TypeScript what type of value a variable refers to. All right, now before expanding on that definition, let's talk about what type inference is. So with type inference, TypeScript is going to attempt to automatically figure out what type of value a variable refers to. Now you'll notice that the kind of definition of both these are very similar. In both cases, it's what type of value a variable will refer to. So the interesting thing about type annotations and type inference is that they're kind of at odds with each other. In one case, you and I are adding in a little bit of code to tell TypeScript what different types we are working with. With type inference, we are relying upon TypeScript to do that work for us. So these two features are a question of, are you and I going to do everything manually, or are we going to leave it up to TypeScript? That's what the big question here is. And that's what is going to be the big focus of our discussion about, why we care about these features and when to use them. Now let's take a quick pause right here. We're going to come back to the next video and start taking a look at a couple of different code samples. So quick pause, and I'll see you in just a minute. In this video, we're going to write out a couple of code examples to understand how type annotations work specifically with variables. Remember, a type annotation is going to be a little bit of code that we write to help TypeScript along. The type annotation system is kind of at odds with type inference. So we're going to first focus on type annotations and then come along and understand how type inference comes into play. All right, so I'm going to change on over to my editor. And inside my project directory, I'm going to make a new folder called annotations. We're going to eventually create separate files inside this directory that are all related to type annotations, so we're going to organize them all inside of here. Inside this folder, I'm going to make a new file called variables.ts. And then inside this file, I'm going to write out my first variable declaration that has a type annotation. So I'm going to write out const apples is going to be a number. I'm going to set that to 5 like so. So the colon and the word number right after it is our type annotation. You're going to see syntax that looks exactly like this in the vast majority of TypeScript code that you work with. This type annotation is trying to tell TypeScript that we are only ever going to assign a value of type number to the variable of apples. If I ever try to assign some other type of value besides a number, I'll very quickly see an error message. So for example, if I update the 5 right here to true, which is a Boolean, I'll see an error right away. And it tells me that the type of true is not assignable to a type of number. Now this is also going to work if I try to update the value assigned to that variable as well. So if I update the const keyword to let, which will allow me to reassign apples, I can then reassign apples down here, a value of 10, without any issue. However, if I try to assign it some other type of value, like a string, once again, I'll very quickly see an error. And once again, I see a message that says, essentially, you have a string and you're trying to assign it to a variable that's supposed to be a number. Now for the rest of this file, I want to show you some reassignments all over the place, so I'm going to continue using the let keyword. Even though in just about all the declarations we're going to add here, usually I would be making use of the const keyword instead. Type annotations like this right here can be used with any type of value. Remember, we just spoke about some of the different types of values inside of TypeScript. So we've got number, strings, booleans, null, void, null, undefined, and functions, arrays, and so on. So with every one of these different types of values, we can use a type annotation. Let's write out a couple of examples just to understand how type annotation works with each of these different types. All right, so in every case, we'll write out let, and then a variable name. In this case, I'm going to call my variable speed, then a colon, then the type of value. In this case, I'm going to say it's going to be a string, and I'm going to assign it a value of fast, like so. Once again, if I try to assign this a value that is not a string, so in this case maybe a number, I'll see an error. And that's pretty much it. We're going to see that same pattern repeating every time we try to assign it a different type of value. Let's take a look at a Boolean as well. So let's say maybe let has name is going to be a Boolean of true. How about null? I'll make a variable called nothing much, and I'll make that null, and that's going to be assigned a value of null. Now this is kind of interesting right here. It's our first example of where we have a value that has a name identical to its type. We're actually going to see that a couple times in TypeScript, and it's something that's a little bit difficult to grasp once you start getting into some more complicated topics. So we're going to have several lectures later on to understand when we're working with something that's a value and when we're working with something that is a type. We could also try a new variable called something like, say, nothing, and make it undefined, like so. Now we can also use type annotation with every other type of value as well, like we just said. So I can use this with an instance of a class, or with a built-in object, or just about anything you can imagine. So let's say that we're working with maybe a date object. I'll put a little section header here, and I'll say built-in objects. So I can make a new variable called now. I'll say that's going to be of type date, and then I'll make a new date and assign it on the other side. So in this case, we're once again doing the same thing we're doing up here. We're saying that we're going to have a variable called now, and we can only assign it a value of type date. And then on the other side, we're going to assign it an instance of a date object. All right, so now that we're kind of getting the idea here, let's take a quick pause. When we come back in the next section, we'll take a look at some of the more complicated syntax that comes up when we start working with objects, arrays, and functions. So quick pause, and I'll see you in just a minute. In the last video, we started to explore type annotations around simple types like number, string, Boolean, and some built-in objects as well. We're now going to write out a couple of examples that use some more complicated syntax. So we'll first start off with trying to add in a type annotation for an array. In this example, I'm going to try to make a new variable called colors, and I want to try to assign it an array of strings. And maybe these strings will be like red, green, and blue because, hey, we're calling this thing colors. So to indicate that, I'll add on an annotation of string and then square brackets like so. So this tells TypeScript that we're going to assign an array indicated by the square brackets that's going to contain nothing but strings inside of it. So I can then place my equal sign and then place the real array and say red, green, and blue. So the important thing here to understand is that the annotation, and specifically this bracket right here, is not creating an array. This is saying we're going to have something assigned to colors that is of type array that contains strings. One of the more complicated things in the world of TypeScript, I think, is kind of separating all this new type annotation syntax and understanding when we are actually creating an array, like as we are here on the right-hand side, and when we are trying to indicate a type of array, as we're doing here on the left-hand side. Now we're going to go into great examples, or much more detail with arrays in just a couple of videos. So for right now, let's just kind of sit on this example right here and say, if we ever want to create a type annotation for an array of strings, that's how we would do it. We can do the same thing with, say, maybe an array of numbers as well. So let's say, how about let my numbers, for lack of a better name, and then I'll put down the type of value that I'm going to have inside of the array, which in this case will be a number, then empty square brackets, an equal sign, and then my real array like so. And the same thing with Booleans as well. So I could say, let, I don't know, truths. How about that? That'll work. That's going to be a Boolean or an array of Booleans. And I'll set it equal to true, true, false, like so. Like I said, we're going to go into greater detail with arrays in just a moment, so we'll just hang it right there. So for our next example, let's take a look at how we would deal with classes with type annotations. So I'll put down another section here called classes, and I'll create a class called car. I'm just going to make it an empty class like so. Classes are another thing that we're going to go into great detail in this course. Again, for right now, I just want you to understand how we can add in a type annotation with an instance of class car. So I could create a new variable down here and call it, say, lowercase car. I'll then put the colon and then the type of the variable, or the type of value that we're going to assign to car. In this case, I want to make an instance of class car. So I'm going to say that my type is capital C car. And this is where things start to get really crazy. If you've never worked a lot with classes before, traditionally we create classes with capitalized names. So whenever you see a capital name like this, like capital car, that means we are referring to the type of class car. And then usually, whenever we have a fully lowercase name, as you see right here, we have a variable that's referring to an instance of a car. So we're saying the variable car is only ever going to refer to an instance of a car. We can then place our equal sign and then make a new car, and that's what creates our instance. All right, so now two more quick examples here. We'll take a look at how we add in a type annotation for an object literal. Now this is where the syntax starts to go a little bit more challenging, but functions are even a little bit worse, so hey, let's just hang in there for right now. I want to try creating an object and adding in a type annotation for it. I'm going to first create the object, and we'll discuss how we can add in the annotation. So I'll make a new variable called point, and I'm going to assign that to an object with an x value of 10 and a y value of, how about 20, like so. So how would we add in a type annotation for this? Well, just like before, we'll add in a colon, and then we'll add in some syntax right here to describe what type of value we're going to assign to point. Now, the only difference this time around is that the syntax is going to look a little bit nasty. So to indicate that we're going to assign an object that has an x property, that's a number, and a y property to number to the variable point, we're going to put the colon and then a set of curly braces, and then we'll list out all the different property names with their respective types right inside of that set of curly braces. So I'm going to say that the object that we're going to assign to point is going to have an x property, that's a number. I'll then put in a semicolon, and then I'll say that it's going to also have a y property, that's a number as well. I only have to put in a semicolon when I'm separating different types inside of here, or different property names. So I do not technically have to put in a colon after the y property, although I can if I want to. So like I said, this is where things start to get a little bit crazy. Once again, we are declaring a variable called point. We are assigning it an object that has an x property and a y property. And then we are simultaneously adding in a type annotation for point as well. And we're saying we can only ever assign an object to point that has an x property that's a number and a y property that's a number as well. So just as we saw a moment ago, back up here at the top, we saw very simply if we assign a bad value on the right-hand side, that doesn't agree with the type on the left-hand side, we very quickly see an error message. So that same rules applies with an object as well. For example, if I make the X property right here a string instead, I'll see an error message. And it says that I have the property called X, but I'm trying to provide a value that is a string instead of the number that I said I was going to provide. So I'll change that back over to 10, and now the error goes away. Likewise, if I do not provide all the required property values, like for example, instead of Y, I instead do something like A, I'll see an error message as well. And the error says, hey, you're trying to give something that has property A, but we were expecting to see something that has Y instead. So the same rule applies. The syntax is just a little bit nastier. All right, so let's do one more quick pause. And in the next video, we'll take a look at the syntax around functions, and we'll talk about why we care about all these type annotations. So quick pause, and I'll see you in just a minute. We've now gotten an example of type annotations with arrays, classes, and object literals. Once again, I just want to remind you that we're going to have a separate section on arrays, classes, and object literals as well. So all I'm trying to do right now is kind of give you a sample of some of the syntax that we're going to need to understand to get through some of the more complicated stuff. The last example I want to give you down here of a type annotation is for a function. Oh, function, there we go. So unfortunately, the annotation for a function is kind of the nastiest syntax, but you're going to see so many examples of it that you're going to understand it really quickly inside this course. So I'm going to first declare a function, and it's going to look like a normal function, and then we'll come back to it and add in the type annotation. So I'm going to make a new function called log number. This is going to be an arrow function, and I'm going to call it with a number that I'll call I, and then inside the function, I'm going to add in a console log for I. Now you'll notice that I've got a little underline right here. Just to get the underline to go away, I'm going to add on I:number like so. We don't need to worry about this syntax just yet. That is not the annotation we are worried about here. So let's just kind of ignore that for a second. Once again, we're going to have a separate section for functions just as we are for these other types of values as well. Right now, all I want to figure out is how we can add on a type annotation for log number right here. Remember, we want to use a type annotation to describe what type of value we are assigning to a variable. So I want to add in some code that's going to tell Typescript some information about this function. Now, in all the other examples we've done so far, the syntax has been sometimes a little bit weird, but more or less understandable. So for example, up here with the arrays, we put down string and then the square brackets to indicate this was going to be an array. In the case of a string, well, that was really easy. We just wrote out the word string. And then we saw with an object literal, we described the different properties and types, or excuse me, the different properties and types of values that the object would have. So in the case of a function, we're going to do something similar. But we first need to think about what properties we really care about with a function. Well, with a function, what you and I really care about as developers is what arguments are going to go into the function and what different types of values we expect the function to return. So that's the information we're going to encode inside this annotation. Inside the annotation that goes right here, we're going to try to tell Typescript what different arguments the function is going to take and what different values it is going to return. So here's what we're going to write out. We're going to write out inside of here. Right here, I'm going to put down a set of parentheses, and inside there, I'm going to provide an annotation for the different arguments that go into the function. So I'm going to say that this thing is supposed to receive an argument with the name of I that's going to be a number. Then right after that set of parentheses, I'll put in an arrow. And then right after that, I'm going to list out the different values that I expect this function to return. Now in this case, I expect this function to return nothing. So I'm going to use a very special type called void. All right, so there's the full annotation. Now I think you can agree with me that this is some really nasty syntax right here. It's really hard to understand where the annotation begins and where the function begins. So everything up to void, like right there, that's the annotation. That is us trying to tell Typescript what type of value we are going to assign to this variable right here. Everything on the right-hand side of the equals is the actual function. So this is the annotation. That's like a comment of us trying to tell Typescript what we are doing here. It is not actual code that's going to be invoked. So even though it really, really looks like a function in its own complete right, it is not a function that we're going to run. It is a description of a function. And then on the right-hand side of the equal sign is where we actually provide the implementation. Okay, I know once again the syntax here is a little bit weird, but don't worry, we're going to have that separate section on functions to really break down the syntax right here and really understand what's going on. All right, so we've now gotten an example of a type annotation with a bunch of different basic values. So now that we've seen all these, I want to point out one thing that's really interesting here. Let's take a look at this first declaration we did at the very top. Right now, if you hover over apples, you'll see a little pop-up that says, oh yeah, apples is always going to refer to a number. So here's the interesting thing. I'm going to remove the type annotation. I'm going to delete that and the colon as well. And now if I hover over apples, I'll see the exact same thing I saw before. So somehow it looks like I didn't really have to add in that annotation in the first place. And that is the entire dynamic that we need to understand between these type annotations and these type inferences. We just learned how to add on a ton of code that are all type annotations. Everything we just wrote, all that new syntax were type annotations. But in that file that we just put together, there was not a single type annotation that was actually required. In other words, inside this file, we did not have to add in a single one of these type annotations. We can delete every single one of them, and everything is still going to work just fine. I can delete all of them, and I still see no errors inside my code. And in every case, if I hover over a given variable, you'll see that I still get a little pop-up telling me what type of value each variable is. So it's very clear that there's kind of more going on here than meets the eye. So let's take a quick pause. When we come back in the next video, we're going to start to understand this kind of tension between type annotations and type inference. So quick pause, and I'll see you in just a minute. In the last video, we saw that we could remove all these different type annotations and we did not see any errors. In fact, if we then hovered over these variables, it's clear that TypeScript still understands what type of value we're going to assign to each given variable. So what you're seeing here is the type inference system in action. In this video, we're going to discuss how type inference works and then discuss when we're going to rely on type inference versus adding in an annotation manually. So let's get to it. All right, so first off, the basics of type inference. Anytime you and I make a new variable inside of our application, we're actually undergoing two separate steps. So on the left-hand side of this equals sign, where we say const color, we're doing something called variable declaration. This is where we are telling our program that we're going to have a new variable inside of our application with the given name. And then in the second step of this entire process, on the right-hand side of the equals sign, we are attempting to assign a value to that variable. Assigning a value to a variable for the very first time is referred to as variable initialization. So this entire line of code right here, two separate steps, first variable declaration, and then initialization. Here's the rule around type inference. If we do our declaration and initialization on the same line, or essentially in one single expression, then TypeScript is going to figure out the type of value that we're going to assign to color for us. So in this case, TypeScript would look at the variable or the value that we're usually using for initialization. It would see that this is a string, and it would say, okay, color must be a variable that's going to refer to a value of type string. And that's how we get this kind of pre-done type right here, where we can delete the annotation and TypeScript still sees what's going on for us. If I move this assignment or this initialization onto a separate line, then it's not going to work anymore. So if I say apples equals 5 on the next line down, if I hover over apples, you'll notice that it has a different annotation on here. It says any in this case. We're going to discuss what any means in just a moment, but for right now, I think you can agree with me that TypeScript can no longer figure out what type of value we're going to assign to apples. So again, the rule of thumb here is if we're doing the initialization and declaration on the same line, TypeScript will use type inference for us. Okay, so that's the kind of easy part of type inference. If we do everything on one line, everything's going to work just fine. So now here's the really obvious question. When are we going to add in these type annotations? When are we going to type them out? If we're saying that TypeScript can figure out these different types for us, why would we go through the process of writing out the annotations manually? And that's a great question. Let's take a look at a diagram to understand why we might want to use type inference over annotation, or the opposite. Okay, so in that file that we just put together, we've got a lot of examples of type annotations. So remember, that's where you and I, the developers, are going to tell TypeScript the type that a value or a variable is going to refer to. Now with type inference, that's where TypeScript is going to guess everything for us. So in general, we're going to rely on type inference always. All the time, wherever we can, we will rely on type inference. That means that whenever you and I have a variable that we are declaring and then initializing on the same line, you and I in this course are not going to add in type annotations. So we're going to have a lot of code that looks like this right here. And we will much more rarely have code that looks like this down here, or anything else that you see inside this file. So we are going to rely upon type inference as much as we possibly can. But there are 3 scenarios where we will rely on type annotations. So let's take a quick break right here, and we're going to go through these 3 different examples of where we are going to add in these type annotations to help TypeScript out. So quick pause, and I'll see you in just a minute. Whenever you and I write TypeScript code, we're going to rely upon type inference quite heavily. This is where TypeScript is going to figure out the different types that are flowing around our application for us. However, there are 3 different scenarios that we're going to look at where we're going to have to add in type annotations manually instead. Remember, these type annotations are going to help TypeScript along. The first example we're going to look at is whenever we have a function that returns the any type and we need to clarify it. Now, we haven't really discussed the any type just yet, so we're going to write out first just a little bit of code, then we'll review what the any type really means, and then we'll get a better idea of why we need to use a type annotation in this case. So let's get to it. I'm going to flip back over to my code editor, and I'm going to go down to the very bottom of the file. Down here, we're going to add in our 3 different examples on type annotations. So I'm going to put in a little comment that says when to use annotations. So case number 1 is when we have a function that returns the any type. Okay, so for this example, I want to define a little snippet of JSON as a string, and then we're just going to try to parse that JSON. So I'm going to define a new variable called lowercase JSON, and I'm going to assign it a JSON string. So I'll put down a string, and then inside of here, we're going to write out just a little bit of JSON. So I'll say curly brace, I'll put down X in double quotes, a colon, and then 10, then Y in double quotes, a colon, and 20, and then I'll close off the curly brace like so. So now I could use that string with the json.parse function and turn the string into an actual object. So I'm going to create a new variable called, how about coordinates, and I'll assign it the result of json.parse with that JSON variable. So in theory, if we now ran this code and console logged out coordinates, we would see something like X is 10 and Y is 20, like so. Now there's just one little gotcha inside of here. If you mouse over coordinates, you'll notice that it has a type annotation of any. So this means that TypeScript thinks that coordinates is of type any. In addition, if we mouse over parse right here, you'll notice a lot of nasty syntax up here, but at the very end of it is something that says :any. That means that the json.parse function returns the any type. So clearly this any thing is something pretty important. Let's have a quick pause, a little aside here, and discuss what the any type means. And then we'll understand, based on that discussion, why we would need to add in a type annotation here, even though it looks like there's no errors or warnings with our code. All right, so quick aside here. So the first thing I want to review is how the json.parse function works. In this diagram, I've got some different values on the left-hand side. And then we're going to imagine that we feed each of these different values into JSON parse, and then we'll take a guess at what the different types are that will come out of the function. Now, in reality, this diagram is just a little bit misleading right here. In reality, anytime we call json.parse, we get back a value of the any type. So this column over here on the right-hand side, I'm just saying this is what the, maybe the type would be, right? This is like, we know that the type of false, once we parse it, would be a Boolean. That's not what we get with TypeScript. This is just like the ideal world. So if we fed in a string of false to json.parse, we get back a Boolean. Again, that's not what really happens. We get back any, but hey, we're just saying we get back a Boolean. If we pass in a string of 4, we would get back a number. If we pass in something that looks like an object with value and then 5, we would get back a type that is an object with value that is a number. And likewise, if we have an object with name that is pointing at a string, we would get back an object with a name property that is a string. And you can see each of these examples very easily if you open up a JavaScript console really quickly and you call, say, json.parse with a string of 5. We get back a number, right? Makes sense. Now, the kind of common theme here is that we can clearly pass in very different strings into this function, and we can possibly get back very, very different value types. In some cases, we might get a Boolean. In other cases, we might get a number. And then in some other cases, we might get these really complicated objects. So the goal of this diagram right here is just to help you understand that anytime we call json.parse, we get back possibly some very, very different value types. Now the problem here is that TypeScript cannot predict these different types. TypeScript doesn't know what we're going to get out of json.parse because it depends entirely on the string that we put into that function. So when you and I are writing code inside of our code editor and we call json.parse, TypeScript just plain can't predict what we get back from the function because it will be entirely different based upon the string that we put in. And TypeScript is not going to try to read this string and figure out what it would return if we called json.parse. So as a shortcut, TypeScript instead decides to simply say, you know what, I can't guess all these different types. That's too complicated. So I'm going to say if you ever call json.parse, you're going to get back something called the any type. The any type essentially means that TypeScript has no idea what type of value is being returned from json.parse. It has no clue at all. And that's what we see inside of our code editor. So right here, when we mouse over coordinates, TypeScript is saying this is the any type. That means that TypeScript has no idea what type coordinates is. So that's what the any type indicates. Now, a couple more notes here on the any type. So any is a type, just as string or Boolean are. Anytime we have to write out a type of a variable, like for example in a type annotation, we could, in theory, put in any just as easily. Anytime we see something that is marked with the any type, that means that TypeScript has no idea what's going on. And in general, that is a very bad thing to have inside of our application. Remember, the entire idea behind TypeScript and all these types and all this kind of stuff is that we're using TypeScript to catch errors inside of our code editor. And we're able to do that because of these types like string and number and Boolean and whatnot. If TypeScript knows the different types inside of our application, it can take a look at any time we say call a function on an object or reference a property on an object. And TypeScript can figure out whether or not we are referencing a property that actually exists or if it's one that we just made a typo on. So anytime we have a value that is the any type, TypeScript cannot do any error checking whatsoever around that value. So for example, right now, if I go back over to my code editor, I can write out coordinates dot blah, 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 like so. This is clearly a property that does not exist. But you'll see that TypeScript does nothing to help me out and tell me that I might have a mistake right here. However, if I go back up to any of these other examples where I'm working with variables that have known type, like let's say, how about speed right here? If I reference speed.blah, blah, blah, TypeScript is going to jump in very quickly and say, hey, that's not a property that exists. It's only going to allow me to call properties that actually exist, like let's say to uppercase, like so. That's fine. And it's only fine because TypeScript knows that speed is a string. So again, anytime we have a variable of type any, it is generally a bad thing because TypeScript can't do its job. All right, so I think that we've gone into enough detail on this any type. So let's have another quick pause right here. We're going to come back in the next video and understand how we can use a type annotation to fix this thing up right here. So quick pause and I'll see you in just a minute. In the last video, we spoke about why the any type is a very bad thing to have inside of our application. Right now, coordinates is of type any, and it's only the case because json.parse returns a value of type any. And that's because TypeScript just can't predict what json.parse is going to return. So to fix this up, one way we could fix it is to add in a type annotation for coordinates. So we need to add in a type annotation for an object. We already saw an example of that right back up here when we defined the object literal of point. So to add in a type annotation for an object, right after the variable name, we're put in that colon, and then the overall structure of that object. So for us, we're going to add in coordinates right here. I'll put in a colon, then a set of curly braces, and inside there I'm going to say this thing is going to have a property called x, that is a number, and it's going to have a property y, that is a number as well. So now we've given enough information to TypeScript that it can figure out what type of value coordinates is. If I now mouse over it, I see the type annotation on here. And now if I try to reference, say, coordinates.blah, blah, blah, I'll very quickly see an error message that tells me that is not a property on that object. Okay, so that's pretty much it. this is one of the 3 cases where we are going to add in type annotations anytime we call a function that returns type any. Now, JSON.parse is just one of the functions in JavaScript that returns type any. There are several others as well. So we'll kind of see some of those different functions over time. And in fact, we might eventually have to write our own functions that return type any as well. All right, so let's take a quick pause right here. When we come back in the next video, we'll move on to the next example or the next case where we are going to add in a type annotation willingly. So quick pause and I'll see you in just a minute. In this video, we're going to look at the final case in which we will make use of type annotations. So this will be whenever we have a variable where its type cannot be reasonably inferred, even if the declaration and initialization are on the same line. This is really going to be a very big corner case right here. Nonetheless, I just want you to understand when we want to use type annotations. So let's try to get through this example really quickly. I'm going to flip back over to my editor, and at the very bottom, once again, I'm going to add in a new section down here, and I'll say this is the third case. This is when we have a variable whose type cannot be inferred correctly. For this example, we're going to create an array of numbers called numbers. I'm going to give it values like -10, -1, and 12. I'll then declare a variable called number above 0. So here's the idea. I want to iterate through the numbers array. If we find a number that is greater than 0, I want to assign it to number above 0. Otherwise, I want to assign false to number above 0. So that means that we're going to have 2 different types of values being assigned to this variable. Now, this is some kind of bad code we're writing right here. I really don't recommend taking this approach in general. However, there are scenarios where you might need to do something like this. Doing it with a number and a Boolean doesn't make a lot of sense, but there might be other cases, like maybe you're trying to find a user's favorite piece of media, and maybe possible choices for media are like a blog post or an image or a book or a movie or something like that. So if we had something like, user's favorite media, it would possibly make sense to assign some different type of values to this variable. So this is kind of where this scenario is going to come up. All right, so we're going to say that by default, number above 0 is going to be false. And then if we ever find something above 0 inside this array, we need to assign that number to number above 0. So let's write this code out. So I'll say for let I equals 0, I less than numbers.length, I plus plus, and then if numbers at I is greater than 0, we'll say number above 0 is going to be that number. So that's going to be numbers at I. Now, as soon as we put that in, we're going to see an error message, and I definitely would expect to see this. So type inference already kicked in right here on this line of code. We assigned false to number above 0, so TypeScript very correctly thinks that this is supposed to be of type Boolean. Then on this line of code right here, we're trying to assign something that is definitely a number to that variable. So the error is that we're trying to assign a number to a variable that is supposed to reference a Boolean. So this is one of the downsides of type inference. Type inference kicked in here, it did its job, but it didn't really understand the intent of our code or what we're trying to do. So because type inference is marking this variable as always being a Boolean, our code won't work as is. So to fix this, we could add in a type annotation. So we could add in something that says colon, and then Boolean or number, like so. And this character right here is the pipe. It is not an L, it's not an I. It is a character right above the return key on your keyboard. You can picture this as being like an OR statement. So this is saying that number above 0 is going to be either a Boolean value or it might be a number, one of the two. So anytime that we need to express kind of like an OR statement with our types, we will have to use a type annotation. Type inference won't work correctly. So by using this type annotation, TypeScript now understands that we can assign a value of type Boolean or a value of type number to this variable. And if we mouse over that variable, it'll be reflected right there as well. All right, so like I said, this is kind of a bad code example, but we could kind of easily imagine some other scenarios where we might have to express a single variable that has possibly different types. And we definitely are going to add some code that looks like this in a future project in this course. So we'll see this kind of scenario of where we have to add in a type annotation, but with a kind of more practical approach. All right, so that's pretty much it. So we now have taken a look at the 3 different cases where we definitely will have to use a type annotation. So let's now take a quick pause. We're going to move on in the next video and talk about type annotations and inference around functions and objects as well. Where's that diagram? Right here. Functions and objects. And we're going to get through these other approaches really quickly because we just had to do some like really original work in this variables section. So quick pause and I'll see you in just a minute. In this video, we're going to continue talking about annotations and inference, but rather than focusing on how those features are applied to variables, we're going to instead focus on how these features are applied to functions. So still talking about working with types, but we're now talking about labeling functions as opposed to variables. Now you might be thinking that we already spoke about functions a couple videos ago, but let's pull open that code snippet that we wrote. Back inside my variables.ts file, we can scroll down a little bit and see where we added in some type annotation around a function. So here's the thing. The annotation that we wrote out right here was an annotation for the variable. We were telling TypeScript, hey, we're going to assign a value to this variable that's going to have this type right here. It's going to be a function, it's going to take some argument and have some return value. Again, it was modifying the variable. So now we're going to be moving on to the right-hand side of that equal sign. We're now going to focus on how we add annotations to the function itself, how we annotate its input arguments and its return values as well. So with that in mind, let's flip back over a quick diagram here. I want to give you a plain definition on what's going on with annotations and inference around functions. All right, here we go. So when we talk about type annotations around functions, we are talking about code that we are adding into our project that's going to help TypeScript along. The goal of these annotations is to tell TypeScript about the type of arguments that a function will receive and the type of value that it will return. So again, we are adding in code here to help TypeScript along, very similar to the type annotations we were already adding in. The big difference here is that we are no longer annotating a variable declaration. Instead, we are annotating the function itself. Now, also with type inference, we still have type inference working around functions as well. Remember, type inference is that kind of automatic system where TypeScript is going to try to figure out what is going on for us. This same system applies to functions as well, but there's one big difference. Type inference only works around the return value from a function. So TypeScript will try to figure out what value or what type of value you are returning from a function, but it will not try to figure out what type of value the arguments are. Now, both these definitions right here, everything I just said, I feel like is kind of confusing. And I think learning all this function stuff is a lot easier to look at some code snippets. So let's flip over to our code editor. We're going to write out a single function and annotate it as best we can. All right, so back inside my code editor, I'll find that annotations directory we had created. I'm going to make a new file in there and call it functions.ts. So inside of here, I want to write out one single function called add. This is going to be a function that's going to take two numbers as arguments, add them together, and return the result. So I'm going to receive those two arguments as names A and B like so. Now, as soon as I add in those arguments, you'll notice I get a little warning. If I hover over them, or just the first one, it says here that A has a any type. So right now, TypeScript has no idea what type of value A is. So to help TypeScript understand what's going on here, we have to add on a type annotation. To do so, right after the argument name, we'll put in a colon, and then the type of value that A will be. So in this case, it's going to be a number. Same thing for B as well. Right after B, I'll put in a colon, and then the type of value that B will be. So we've now defined a function that's going to take two arguments, A and B, and they're both going to be numbers. Now the last thing we'll do is add in an annotation for the type of value that the function is going to return. Remember, we had said that the add function was going to add two numbers and return the result, so it makes sense that this thing will return a number as well. To add in that annotation, right after the argument list, I'll put in a colon, and then the type of value that the function will return. In this case, a number. As soon as I add that in, you'll see that I get an error right here again. This time it's saying that I have a function whose type is neither void or any, and it must return a value. So all this is saying right here is that we just added in an annotation that said our function was going to return a value that is a number. But we don't have any return statement right now. We don't have any code to actually return a number. And so TypeScript is telling us, hey, your function isn't working as expected. So to fix that error, all we have to do is return a number. So inside the function, I will return A plus B like so, and then that error goes away. All right, so this is a very basic example right here, but it highlights some really important ideas around type annotations for functions. So let's take a quick pause. We're going to come back to the next video and dissect this thing just a little bit more. So I'll see you in just a minute. In this video, we're going to dissect the add function just a little bit and get a better idea about how type annotation works with functions. So once again, every time we add in an argument list, we're always going to annotate every single argument. Likewise, right after that argument list, we're going to add an annotation for what the function will return. Now, when we add in the return annotation right there, TypeScript is going to immediately analyze the body of your function. So it's literally going to read the code inside there and decide whether or not you actually are returning a value that is a number. In this case, TypeScript knows that A and B are numbers. It sees that we add them together. It knows that adding two numbers together results in a number, and then it sees that we return that value. So TypeScript can read this line of code right here and understand that we have done exactly what we said we were going to do. If we return some other type of value from the function, like a string like so, we'll very quickly get an error because now TypeScript has read the body of our function again and seen that we are returning a string as opposed to the number we said we were going to do. So if I hover over that, it says specifically, hey, you're trying to return a string, you're supposed to return a number. And so I can revert it back over to A plus B. Now, one really important thing to understand here, and this is kind of getting into one of the more interesting sides of types, although we've declared what type of value we are going to return, TypeScript is not going to try to make sure we actually have the correct code inside the function. Now, I know that sounds kind of weird, but let me tell you what I mean by that. You and I wrote a function here called add. And so I think any engineer who looks at this function would say, okay, if I call this, it's going to add two numbers together. And then we added in some annotation to say, oh yeah, the function's going to return a number. TypeScript can make sure that we are returning the correct type of value, but it does not actually try to make sure that we have the correct logic inside of our application or inside this function. So in other words, we could very easily return the difference between A and B. So no longer are we adding, we're now subtracting. But TypeScript doesn't care about that. It just says, hey, you're returning a number, works for me. Now, this might seem like a really obvious thing, but it's going to have some really big impacts on some later topics we discuss. Remember, the type system is just concerned with types. It doesn't actually vet your actual logic inside the function and make sure you're doing the right thing, so to speak. All right, I am going to restore that to A plus B. Now, the last thing I want to mention here is just a little bit more around annotations and type inference. So quick diagram of this function. All right, here we go. So here's our add function. We have two arguments into it. They are both numbers. And we have a single output that is a number as well. So when we think about the arguments, we have to always use type annotation. In other words, we have to write out colon number right there, every single time we define a function. There are some corner cases where we do not, but for right now, we'll just kind of ignore those. We'll discuss them later on. So whenever you and I write a function in this course, we are always going to add in these annotations every time we write out a function. So we do not get any type inference on arguments. We're always going to add in those annotations. However, on the other side over here, for the output from the function, we do get the benefit of type inference, but we're not going to use it. And so let me clarify what's going on there. Back over inside my function, I'm going to find the return value annotation right here and delete it. If I now hover over add, I'll see an annotation on the variable itself that says that add is referring to a function that takes two numbers and returns a number. So that's type inference in play. We did not add in a type return annotation, but TypeScript read the body of our function and it knows that we are going to return a number. So just like we saw with inference before with variable declarations, we have type inference around only the return value from a function. So we don't have to add in that return annotation if we don't want to. However, like I said, you and I always will. And here's why. Let's imagine that we've got another function here called subtract. And this is also going to take two arguments, A and B. They're both going to be numbers, and I'm going to leave off the annotation. So then inside of here, we'll just subtract the two numbers like so. And yeah, okay, I think that's it. We're good to go. So do you notice anything missing here? Well, I didn't put on a return statement. So if I hover over subtract right now, you'll see that we get an annotation on here that says that we have two arguments as inputs, A and B, and then we have a return value of void, which means that we are not returning anything at all. So TypeScript has used type inference here to say, hey, since you're not returning anything from the function, I guess you don't mean to return anything from the function. We made a mistake. We did not return a value, and TypeScript has not done anything to tell us that we made a mistake inside of this function. So if we instead add in an annotation for the return type right here of number, like so, we'll very quickly see an error message. That would be our signal that, hey, we probably made a mistake inside the function, and we should add on a return like so. So that's why you and I are always going to use return annotations. It's because we could very easily make a mistake inside of a function and forget to return a value, or even return an incorrect type. If we do so, TypeScript is not going to give us an error. It's just going to think, oh, that's what the developer meant to do. The only way that we're going to get an error is if we add on that annotation right there. So like I said, although we get inference on the output from my function, we are not going to use it. We're always going to add that annotation in. All right, so that's functions in a nutshell. One or two quick more topics, so quick pause, and I'll see you in just a minute. In this video, we're going to take a look at some alternate forms of syntax around annotations for functions. So underneath my two functions I already have, I'm going to define another one called divide. And you'll notice I'm going to use the keyword function right here. So how do we use these annotations with a function defined with the function keyword? Well, basically the exact same way. So we'll have two arguments, A and B, and we need to annotate both of them. So we'll say A is going to be a number, and B is going to be a number as well. Then to annotate the return type of this, again, right after the argument list, we'll put in a colon, and then the type of value we expect to return. Then we can return A divided by B like so. Now this syntax is going to also work for anonymous functions assigned to variables too. So I could say const multiply will be a function. This will take two arguments of A and B, once again, both numbers. And again, right after that argument list, we can annotate the return type as well. And so then inside the function, A times B like so, and that's pretty much it. So anytime that we need to define a function using an arrow, a named function, or an anonymous function assigned to a variable, we're always going to see a near identical form of syntax. It's always going to be the arguments with a colon and then the expected type. And then immediately after the closing parenthesis, we'll do another colon and the expected type of the return value from the function. And that's pretty much it. Okay, quick pause here, and we'll talk about one last thing in the next video. In this video, there's one last quick thing I want to mention, and that is one very special type that we haven't really discussed too much, except in kind of passing. So at the bottom of this file, I want to define one more function. I'm going to define a function called logger. This thing is going to take some message that is a string. And then inside the function, I want to just console log that message, like so. So the only goal of this function is to call console log, and it does not actually return any value. So there's no return statement inside of here. To annotate this fact, as a return type, we'll put on colon void, like so. So void right here means that we have a function that's going to not return anything. Technically, a function that returns void can return null, and it can also return undefined. But effectively, we use void right here to say there will be no return value from this function. If we ever accidentally return something, like so, we'll very quickly get an error message that says, hey, you can't return anything at all. Now there's one other very special type associated with function return values as well. So I'm going to make one more function in here called throw error. And throw error will also take a message that is a string. And then anytime we call this, I'm going to immediately throw a new error with that message like so. Now just so you know, anytime you throw an error, the function will technically not actually return anything. So to indicate that, we could put on a colon right here that says never. And that means that we are never going to actually reach the end of this function. So we're never going to execute the function completely. At some point in time inside of here, we're going to throw an error and exit the function early without returning any value. Now this is a really big corner case. It's actually pretty darn rare that we're going to want to intentionally throw an error like this. It's much more common for us to have some like actual return value in here. Like let's say if there is no message for some reason, then we will throw an error. And then otherwise we will return like, I don't know, maybe just the message like so. And so in this case, we would still annotate this as returning a string, even though it throws an error. So we only annotate a function with the type never when we really, truly never expect a function to return anything ever. If we at least expect it to return something eventually and only possibly throw an error, that's totally fine. We're still going to annotate it with whatever we expect it to eventually return. And that does include the case where we return nothing like so. So in this case, we would still do a fallback to void because we are technically not returning anything, and there's just a chance of us never reaching the end of the function. Okay, so that's pretty much it. Let's take a quick pause right here and move on to our next subject. There's one last quick thing I want to mention around functions. So down here at the very bottom, we're going to add in one last example here. Let's imagine for a second that we have some object that describes today's weather. So maybe we call it forecast like so, and maybe it's got a date to indicate today's date, and the current weather outside. So maybe that will be a string that we'll call sunny, like so. Now let's try creating a function that's going to take that forecast and just log out the weather. So to do so, we could say something like const log weather, and then we're going to get some forecast object, and we need to annotate the return type, or the argument type right here. So to do so, we would put in an object literal, just like we saw previously with our variable annotation, like what we saw right here. So we would put in a colon, and then curly braces, and list out all the different properties that we would expect this forecast object to have. So maybe it will be a date that has a date type, and a weather that has a string type. I'm going to zoom out for just a second so you can see that whole line. Then after the list right there, I'm only going to try to log out the current weather, so there's not going to be anything I'm going to return. So I'll mark the return type as void, and then put down my arrow for the function like so. Okay, I'm going to zoom back in. So now if we wanted to, we could do a quick console log of forecast.date and a console log of, say, forecast.weather, like so. And then just as a quick example down here, we could try calling log weather with the forecast object. Now just to make the variables in here a little bit more clear, maybe rather than calling this forecast, it should be like today's weather. Maybe that makes a little bit more sense. Now it's better. All right, now one little optimization we could do here would be to use a little bit of ES 2015 syntax and attempt to destructure the date and weather properties out of the forecast variable right there. So in other words, rather than having to refer to forecast.date and forecast.weather, I want to just pull those two properties directly off inside the argument list. If we were using normal ES 2015 syntax, I'll put a quick example right here, we would write out something like this. We would say const log weather, and then inside the argument list, we would put a set of curly braces and list the two properties we wanted to access. So in this case, date and weather, like so. And then we could do a simple console log of date and of weather. So how do we use this kind of syntax right here with a TypeScript annotation? All right, I'm going to remove the ES 2015, and we're going to adjust the syntax in here just a little bit. So if we ever want to use destructuring along with an annotation, all we have to do is replace the variable itself with the actual destructuring statement. So instead of forecast right there, I'm going to replace it with a set of curly braces, and I'll list out the different properties I want to pull out of that object. So it'll be date and weather, like so. And then I can adjust the body of the function to be just date and weather. So notice that we did not try to stick the annotation types along with the destructuring. The destructuring portion and the annotation are always going to be two separate statements separated by that colon right there. So we're first going to do our destructuring, and then we'll try to do the actual annotation right after it. All right, so now we've seen that. Another quick pause right here, and we'll move on to our last subject around annotations and inference. I know we've spent a lot of time talking about annotations and inference, but we've got just one last little subtopic to discuss, which is objects. Now, this discussion is going to go a lot more quickly because all we're really discussing here is how we do stuff like object destructuring, which we kind of saw an example of in argument list just a second ago. So let's just flip directly back over to our code editor and talk about how to work with objects around this annotation stuff. So inside my annotations directory, I'm going to make another file called objects.ts. And then inside of here, I want to declare a new object called profile. And this will be a profile for a person. So maybe they have a name like Alex, maybe they have an age like 20. And we'll say that this person also has some coordinates, like their physical location in the world. So I'm going to abbreviate that as simply coords. And then I'll give them a latitude and a longitude property inside there. So we've got a nested object right here. We've got the latitude and longitude representing this person's physical location in the world. Now, last thing I want to add to this object is a method that will change the age of this person. So obviously we could do something like, profile.age equals 20, but let's make a separate function just to have a nice function to call. All right, so one more property we'll add in here is setAge. And rather than defining this as like a function like so, I want to try using the ES2015 syntax for defining a method inside of an object. So instead, I'll say setAge, I'll put my argument list in, and then the function body. So let's try adding in some annotation for this function right here, using the same rules that we just learned. So I'm going to put in a age as an argument, and then the type of this argument, which will be a number. If we're just updating this person's age, I don't really expect to return anything from this function. So I'm going to annotate the return type as being void like so. So then we can write out our implementation inside the function. We can say this.age is age. All right, so that's an example of a function being defined inside of an object with the function annotation on it. So let's now try doing a little bit of ES2015 destructuring and pulling some different properties out of this profile object. So for example, let's try destructuring out the age property right here and figure out what the exact syntax for that would be. So of course we could do something like const age is profile.age, but like I said, we want to use destructuring instead. So instead, I'm going to write out just profile, and we can do normal destructuring like so. Now, if we really wanted to put a type annotation on here for some reason, like maybe we fall into one of those three categories that we discussed earlier, right here, if we really wanted to put on some annotation directly onto the variable right here, we could do so by writing out a colon and then the structure of the profile object. So we would not just say, oh, this thing is going to have like age that is a number. Instead, we have to list out the structure of profile and the different properties that we want it to have. So in this case, we would put down curly braces, age, and number like so. So notice how this seems to kind of like violate the rules of annotations. Previously, when we were talking about variable annotations, we had said, oh yeah, we just put the type of the variable or the type of value that we're going to assign to this variable. So we're creating a variable right here called age. And so you might think that we only have to label it with the type that age is going to refer to, which would be number. But that's not the case. If we want to use destructuring, we have to write out the expected structure of profile over here on the right-hand side. So I expect this value right here to have a structure that is an object with an age property that is a number. So now to make things just a little bit more complicated, let's try also destructuring out our latitude and longitude as well. So this is going to be some nasty stuff, but it'll be some pretty good practice. So we would write out one set of curly braces. We would say, look at the coords property, and then try to pull out latitude and longitude out of there. And we want to get all that from the profile object like so. Okay, so if we were just doing plain destructuring without an annotation, that is what it would look like. So it'd be just identical to the normal ES2015 syntax. But once again, if we fell into one of these conditions where we had to put in an annotation, all we would have to do is once again kind of mirror the object structure that we expect profile to be. So it's going to be a little bit nasty here. Right after the destructuring, we can put in a colon. Then we'll start to describe the structure of the profile object. So I'll put a set of curly braces. I'm going to say that this thing is going to have a property coords. That's going to be an object. And inside of that inner object, we've got a lat property that is a number. And an lng property that is a number as well. Now this is a really long line, so I'm going to save the file really quickly just to get it to reformat so you can see the whole line in total. So once again, kind of unexpectedly, we do not just list out the expected type of lat and long. And I think this example right here will give you a better idea of why that is. If we consider back up here, if we had only put number, well, what would happen if we wanted to destructure multiple properties and also pull out, say, this person's name as well, which was a string. If this was the case, is number referring to the type of age or name? So this is why we have to kind of double up on the structure whenever we are doing the destructuring. So age is a number and name would be a string. We have to label the type of all the different properties coming out of that object. Now in this case, you'll notice I've got a little error here around name. That's totally fine. It's just because of the way my project is structured. Chances are you see an error here as well that says something like name was also declared. If you see that, totally fine. You can ignore it. All right, so that's it around objects. Like I said, I just wanted to very quickly talk about destructuring around objects and what annotations for them look like, and also how we tuck in function declarations inside of there as well with some annotations. Okay, so that's pretty much it on type annotations and type inference. So we've gone over several plain definitions, went over some examples. We spoke about why we care about these. Remember, it's because we want to make sure TypeScript is aware of the type of all the variables we work with. And we also discussed when we're going to use annotations and when we're going to fall back to inference. Whenever we're working with functions, we're going to rely upon annotations 100% of the time for both arguments and return types. When we're working with variables, we're going to rely upon type inference as much as we possibly can, unless we are relying upon or in one of these three scenarios right here. All right, so now that we've got through a lot of this kind of boring stuff, let's take a quick pause right here and continue on our next subject in the next video. In this video, we're going to start to discuss arrays in TypeScript. As usual, we'll start off with a plain definition, then walk through some examples, and then talk about why we care about these things and when to use them. So let's get to it. First, a quick definition. When we work with arrays in TypeScript, we are essentially working with plain JavaScript arrays. So we still have all the features that you are already used to. We can push elements into an array or pop elements out. We can map over an array, write a for each loop, use a for loop, all that kind of good stuff. The one big difference with arrays in TypeScript is that generally we only stick elements with a very consistent type into the array. So for example, if we make an array that is supposed to contain strings, we will only put strings inside there. And if we try to put a number in or a Boolean, we're going to very quickly get an error message. So in general, when we work with arrays in TypeScript, we're making use of one specific type of element inside that array. We can technically put different types of values inside of an array, but if we want to do so, we have to be very explicit about it and add in a special little type annotation. And we are going to look at a quick example of how to do that as well. All right, so as you might guess, pretty critical to look at some code samples here. So that's the only definition we're going to get. Let's flip on over to our code editor and start writing out a little bit of code. So back inside my editor, I'm going to make a new file inside of my root project directory called arrays.ts. Then inside of here, I'm going to declare an array and just assign it to a variable. So I'll say const car makers is going to be an array of strings that has strings like Ford, Toyota, and Chevy, like so. If I now hover over that array right there, you'll notice that I have an added on annotation that says that car makers is going to be an array of strings. So this is type inference in action. TypeScript took a look at the value inside this array right here, and it said, okay, looks like those are all strings, so I guess car makers is always going to point at an array that only contains strings. Now that's type inference doing that for us automatically. Remember, if we wanted to be really explicit about this, we could always put on a colon, a string, and then square brackets like so. So that's a type annotation that says that this variable is always going to point at an array that contains nothing but strings. We will sometimes want to add in type annotations when we are working with arrays. So the case in which we would want to do that is if we initialize the array as an empty array, like so. In this case, if we did not have the annotation on here, TypeScript would not have enough information to understand what type of value was going to be inside that array. So for example, if I now hover over car makers, it says any array, and that means we can put any type of value inside there. Remember, we want to avoid the any type as much as possible. So if we ever have to initialize an array as an empty array, we will add on our annotation. So I'll put in string like so. Otherwise, if we're going to initialize our array with some contents already inside of it, then we don't need that annotation. All right, now we're not limited to just putting basic values inside of arrays. We can also put complex objects inside as well. So for example, let's try creating a new array here called dates. And I'm going to be creating an array and assigning it a variety of new date object instances. If I now hover over dates, once again, it'll tell me that this is going to be an array that contains instances of dates. Next up, we can also write out two-dimensional arrays inside of TypeScript very easily. To do so, we're just going to double up on the syntax around that annotation we put together. So for example, let's say we've got an array called cars by make, and I want to have like a 2D array of strings inside of here. So inside of the first element of the outer array, I'm going to put a new array inside of here, and then I'll put in like some actual model of car made by, say, Ford. So maybe an F-150. And then at the second index, I'll put in a car by Toyota, which is a Corolla. And then finally, something by Chevy. How about a Camaro? Like so. So if we now hover over cars by make once again, we'll see the type annotation for a two-dimensional array. In order to indicate a two-dimensional array, we'll write out the type of value that goes inside the inner array, then one square bracket and a second square bracket. So that means that we're going to have an array that contains arrays of strings. Right there, that's the inner array of string indication right there. Once again, we don't have to add in that annotation if we don't want to. The only time we would is if we didn't have any contents in the array when we initialized it. So in this case, we would write out string, square bracket like so. Now, like I said, when we type an array, we're putting on a restriction on what type of value we can put into it. So let's have a quick pause right here. When we come back in the next video, we'll see a very quick example of that. In this video, we're going to take a look at another example of when we're going to add in a type annotation manually. So this is going to be whenever we declare a variable on one line and then initialize it later. As a quick reminder, type inference only works when we do variable declaration and initialization on the same line. And so obviously, if we split this into two separate steps or two different lines of code, then type inference doesn't work anymore. All right, so I'm going to flip back over to my editor. I'm again at the very bottom of my variables file. I'm going to set up a second example here. I'm going to say, when we declare a variable on one line and initialize it later. Okay, so for this example, I'm going to make an array of strings called words, like so. And I'm going to give this the words red, green, and blue. Then right after that, I'm going to declare a variable called found word, like so. So here's what I want to do. I want to write a for loop that's going to iterate through this array right here. And if I ever find a word or a string equal to green, then I want to set found word to true. So if you find green inside of words, just set found word to true. That's pretty much it. I know this is a silly example, but I just want to give you a very practical example of when we're going to run into this type annotation stuff. So I'm going to write out my for loop. I'm going to say let I equal 0, I less than words.length, I plus plus. And then for every word, we'll say if words at I is equal to green, then we'll set found word equal to true, like so. So now in this case, I have an instance where I'm declaring the variable up here, and then I only assign it a value or initialize it down here inside of my for loop. If I now mouse over found word, it will very clearly tell me that this is of type any. And in fact, I even have a little underline here that is a warning that tells me that found word has an implicit any type. And then the tip here says that I might get a better type if I actually use the variable. Now, when it says inferred from usage, that actually means that like I have to add in the annotation right here or optionally initialize it on the same line. So in this case, to make this warning go away, we have to add in a type annotation. So I can tell Typescript, all right, this is going to be a Boolean. And now we get around that issue. So whenever type inference doesn't work because we are doing declaration and initialization on separate lines, we're going to add in the type annotation. That's pretty much it. Now, as a quick aside here, obviously the best way to write out this code would have been to do something like this, to initialize found word as false, and now Typescript understands what's going on here. This is way better code than what we had before, but again, I just wanted to give you a quick example of where we might have a declaration on one line and then initialization at some future point. All right, so let's take a quick pause right here. When we come back in the next video, we're going to take a look at our final example of when we are going to prefer to use a type annotation. So quick pause, and I'll see you in just a minute. Now that we've seen a couple of examples of arrays, I want to walk through some kind of corner cases around them. So essentially, I want to discuss why we care about these arrays. Like, what's so big a deal about arrays in TypeScript that we're making this into a separate topic? Well, here's why. When we work with arrays in TypeScript, we got a couple of different advantages and a couple of different downsides as well. So first off, TypeScript can help us when we make a typed array by helping us do type inference whenever we are pulling a value out of an array. Let's see a quick example of that. So back over inside my code editor, I'm going to put a little comment down right here, and I'll say help with inference when extracting values. So in other words, if we look at our car makers array right here, we know that it is an array of strings. TypeScript knows that as well through type inference. So that means that if we ever pull an element out of this array, either by using, say, the pop method or by direct index access, TypeScript will know that we are going to be pulling out a string and help us with type inference with the new variable that we're assigning this value to. So let's take a look at an example of that. Let's say that I'm making a new variable right here, and I'm going to call it something like car. If I then take car makers and do an index access to it, I can now hover over car, and you'll see that type inference has come into play, and TypeScript knows that this variable is going to be a string. It knows this because it knows that car makers is an array of strings, and we just pulled one value out of it. Likewise, this also works if we try a pop method. So let's say we've got my car, and we do like car makers dot pop, like so, to remove the last element in the array. Once again, TypeScript knows that car makers has an array of strings, so when we call pop, it's going to return an instance of a string. So we can once again hover over my car, and we see, yep, TypeScript has correctly inferred that my car is going to be a string. All right, so that's one benefit of making use of arrays in TypeScript. Secondly, TypeScript can help us prevent us from adding in incompatible values into an array if we have correctly typed the array. So for example, back over here, once again, we can say prevent incompatible values. So once again, if we take our car makers array right here that only contains strings, and we try to add in some element that is not a string, like let's say a number, we'll very quickly see an error message. TypeScript is telling us here, hey, you're trying to put in a number to a collection that is only supposed to contain strings. So that's going to help us from putting in dissimilar elements into one single array. Now, once again, if we want to have multiple different types in an array, we definitely can do that, but we have to use some special syntax to do so. We'll take a look at an example of that in just a moment. All right, third, anytime we declare an array, we get a lot of help with built-in functions like map, for each, reduce, and so on, whenever we are iterating over a collection of elements. So for example, if we flip back over once again, we get help with map or for each and reduce. So for example, if we do car makers dot map, we can add in a function right here that will be called with every element in the array. So I'm going to receive each car as a string, and from this, I'm going to return, say, a string as well. We'll just do a straight pass through here. So I'll take the car and return it immediately. So TypeScript is going to make sure that the value that we are putting into this function right here will be a string. And so because of that, because TypeScript knows that car is going to be a string, we get access to a lot of different autocomplete on the variable that comes in here. So for example, if I put in a dot right after car, I can then see the autocomplete appear with all the different methods that belong to strings. So for example, I can do a to upper case, like so. So anytime we start working with map, for each, reduce, or any similar helpers, TypeScript is going to give us autocomplete on the variable being passed into this function right here, which is a nice little benefit. All right, now the last item we're going to talk about right here is that we can in fact put different types of elements inside of an array. Let's take a quick pause though, because there's a couple different corner cases around this and some interesting syntax we need to understand at the same time. So quick pause, and I'll see you in just a minute. In this video, I want to show you how we can still use arrays with multiple different types of values inside them. So let's flip back over to our code editor and once again write out a quick example. So I'm going to put in a new comment down here that says flexible types. And then I'm going to declare a new array called important dates, like so. So this is going to be an array that contains some different important date values. Maybe some of them are going to be instances of date objects, and maybe some of them are going to be strings that contain like a date inside them. So in other words, I want to have two different types inside this array. Some are going to be instances of date objects, some are going to be strings. So to do so, I could simply write out a new date, and then like an actual string in here, so 2030 maybe, 10, 10, like so. If I now hover over important dates, I'll see an updated little type annotation here. So in this case, notice that little pipe operator right there. We've spoken about that very briefly before. That's kind of like an OR statement for types. So this can be read as saying this is going to be an array that contains elements that are a string or a date. So everything inside this array can be treated as a string or a date object. Now, it is important to understand this annotation right here. If you ever happen to, say, only initialize the array with date objects, and we hover over this once again, TypeScript now thinks that this array will only contain dates. So if we wanted to specifically say that this array can contain multiple different types, we would once again have to add in a manual annotation here. So I could put in a colon, and then just like that syntax we saw in that tooltip, we would say date or string, and then the square brackets right after. And so now once again, if I hover over important dates, we've overridden type inference and said specifically this array can contain either type of value. So now, right after that, we could do important dates.push and add in a string. Well, let's do a real string here. So 20, 30, 10, 10. And important dates.push new date like so. And as you might guess, if we now try to put in a new value that is just like a plain number, we will see an error because that is neither a string nor a date object. Now, as we mentioned before, you will want to put in this annotation if you ever do not initialize the array with a date literal and a string literal. Alternatively, if you initialize it with an empty array, you will want to have the annotation on there as well. If we don't put on that annotation with an empty array, we're always going to end up with an array of the any type, which we always want to avoid as much as possible. All right, so that's how we put in multiple different types of values into one single array. Now let's take a quick pause right here and talk about where we are going to actually make use of these typed arrays. And as you might guess, it's probably going to be everywhere. So quick pause, and I'll see you in just a minute. In this video, we're going to do a quick wrap up on arrays and discuss when we're going to use them. Well, pretty simple and straightforward. As you might guess, we're going to use an array in TypeScript anytime we want to represent a collection of records, usually with some very similar type about them. Now, this might seem like a silly lecture to put in here, like I'm sure you've got a good idea of when to use arrays, but it turns out that there is another very similar data structure in TypeScript, very similar to arrays, called tuples or tuples. So we're going to talk about tuples in just a second, and they're going to look very similar to arrays, but with some distinct little differences about them. So for right now, I just want you to understand that we're going to continue to use arrays anytime we want to represent a collection of different records. All right, so let's take a pause right here. When we come back to the next section, we're going to start discussing tuples and how they're just slightly different from arrays. So quick pause, and I'll see you in just a minute. In this video, we're going to follow up on arrays by discussing a very similar data structure called a tuple. Now, you'll sometimes also hear this pronounced as tuple. Totally up to you, either tuple or tuple, either way you want to do it. So as usual, definition, examples, and so on. All right, so first off, quick definition. So when we are working with a tuple or a tuple, we have something that looks very similar to an array, very, very similar. But the big difference here is that we are going to have every element inside of this array-looking thing represent one specific property about some record. So whereas an array tells us a bunch of different records or organizes a collection of different records, a tuple usually contains multiple different properties to describe one single thing. And as a follow-up to that, usually inside of a tuple, we will mix and match many different types of data inside there. So let's take a look at a quick example. All right, I want you to imagine that we've got some object like the one you see right here. And the goal of this object is to represent a drink, like in this case, soda or pop, whatever you want to refer to it as. So maybe inside this object, we have a color property that is a string of brown, carbonated that is a boolean of true, and sugar that is meant to represent the sugar content of the soda in grams. So that will be a number here. So as you might guess, this would represent maybe like Coca-Cola or Pepsi or something like that. So representing a drink or a soda with an object like this, I think makes a lot of sense if you're coming particularly from a JavaScript background. We've got one object to represent one drink, and this object has some properties that describe what is going on with this singular drink. Now, just for fun, I want to take this object right here, and I just want to try to represent it with a slightly different data structure. Let's try to represent this object with an array instead. So how can we do that? Well, maybe we would say that we would take each of these values, so like brown, true, and then 40, and stick them into this array like so. So now we have a slightly different looking data structure that still represents a drink. In turning this into this array right here, we have lost a little bit of information. In other words, you and I as developers can very easily look at an object declaration like this right here and very quickly understand, okay, the color is brown, carbonated is true, and sugar is 40. When we start to represent this object as an array, we've lost those different property labels on here. And so you and I as developers would have to memorize the fact that the first element inside this array is supposed to be a string representing the color. The second element is supposed to be a Boolean representing whether or not the drink is carbonated. And then the third element inside there is a number representing the sugar content. So the big difference between representing this as an object and something that looks like an array is really just that loss of information in these labels. No longer is our code really self-labeling. Instead, we have to kind of memorize the order of properties inside of here. So this is exactly what a tuple is. We have what looks like an array, and we put in our property values into that array in a very specific order. So the ordering part is really critical. If we start to arbitrarily swap around elements inside of here, we are no longer going to understand which different value represents which property. So if you and I have memorized, like as developers, that this array is always supposed to tell us the color, then the carbonation, and then the sugar content, and we swap some elements inside of here, and we don't have those labels, now this is kind of a meaningless record because we're now trying to indicate that our color is 40, carbonation is true, and sugar content is brown. So when we work with a tuple, we have a fixed series of elements, or a fixed order, I should say. All right, now let's take a quick pause right here. We're going to come back to the next section, get some more examples around tuples, and start to write out some code around them. So quick pause, and I'll see you in just a minute. Now that we've got a basic understanding of what a tuple is, let's try writing out a little bit of code to understand how we work with them in TypeScript. So back inside my editor, I'm going to make another new file inside my project directory called tuples.ts. Then inside of here, to get started, I'm going to write out an object that looks like that drink object that we just put together, or was inside that diagram. So I'll say const drink is going to be an object with a color of brown, carbonated is true, and sugar is 40, like so. So a object works perfectly here, right? You and I can read this and very easily understand what's going on. However, we have access to tuples as well. So we could alternatively try to represent this with a tuple. To do so, we could write out, let's say, some new drink here, like maybe Pepsi. And then I'm going to write out what looks like an array. And I'm basically just going to take the different values out of this object and put them into this array in a very specific order. So I'll put in brown to represent the color, then true to say that it's carbonated, and then 40 to represent the sugar content. In this case, like 40 grams, say. Now here's the only issue. What we just defined right here is an array. So if you hover over Pepsi right here, take a look at that type annotation. This is saying that Pepsi is going to be a string or a number or a Boolean array. So the issue right now is that we could freely swap the order of elements inside of here. And in general, we don't want to do that. Because remember, the order inside of a tuple has a very specific meaning to us. You and I, as developers, have to memorize that the first element inside of here represents the color. And then the second element represents carbonation, and the third represents sugar content. So if you and I start to write out some code that's going to swap the order, like let's say Pepsi at 0 is now going to be 40, and Pepsi at 2 is now going to be brown, we have lost information. So you and I, as developers, have an assumption about the order of elements inside of here. And if we start to break that order, our data model completely breaks down. So we're not going to define this thing as a simple looking array in TypeScript. Instead, we're going to add on an annotation to this thing. This annotation is what's going to turn this line, or this array right here, into a tuple. So right after Pepsi, I'm going to put in a colon, and then rather than putting out a type right here and then square brackets, I'm going to instead put in a pair of square brackets, and then inside of here, we're going to write out the specific order of types of elements inside of this tuple. So I'm going to write string, then Boolean, then number, like so. So this is what makes this thing into a tuple as opposed to an array. We are saying that this array is going to always have a very consistent ordering of elements inside of it. Always a string, then a Boolean, then a number. So you and I as developers can read this thing right here and understand that there is some meaning to the order of elements inside of this array looking thing, or I should say tuple. If we now try to change the order of elements inside of here and say Pepsi at 0 is now going to be 40, we'll very quickly get an error message. The error message is going to tell us that we're trying to assign a number to an index inside that tuple that is supposed to be a string. So again, by putting on this different looking type annotation right here, we are turning this array into a tuple. An alternate way of writing this thing out right here, rather than putting the type directly in line as an annotation, would be to create something called a type alias. We're going to discuss type aliases at great length later on inside this course, but this is a very good place to use a type alias, so we're just going to cover them very quickly right now as a quick aside. So rather than having to repeat out this definition right here every time we want to create a drink, we can instead, right above, write out type, and then maybe drink with a capital D, and then we'll list out the tuple structure. So it's going to be a string, Boolean, and then number. This does not create an array right here. So no array is being created. Instead, it's creating the idea of a tuple inside of our application. It's a brand new type that we can freely use in any place that we would normally put a type. For example, in a type annotation. So now rather than manually writing out all the different types right here, I could instead say drink like so. And this is 100% equivalent to what we just had a moment before. So now I can very easily reuse this tuple structure and say maybe Sprite is also a type of drink, and it will be clear, it is carbonated, and maybe it also has a lot of sugar. And then maybe we also have tea, that is a drink, and maybe it's also brown, not carbonated, and 0 sugar like so. So we've now abstracted out the idea of what a drink is into a type alias. Now we can freely reuse it throughout our application to indicate that each of these different things are not plain arrays, instead they are a tuple that represents a very specific record inside of our application. All right, now I'm going to be honest with you, we are not going to use tuples very often. So let's take a quick pause right here. We're going to come back in the next video. We're going to discuss why we care about these things and where we're going to use them. And we're going to find out that maybe tuples are not super useful in TypeScript. So quick pause, and I'll see you in just a minute. In this video, we're going to discuss why we care about tuples and when we might use them. Now, I'll be honest with you, I am not a huge fan of tuples, and I don't think you're going to really be using them in a very regular basis with TypeScript. There are a couple exceptions. Most notably, I think that if you're ever working with a CSV file and you want to represent, say, a single row, you might reach out to a tuple. We'll actually work with the CSV file later on inside this course, and so you'll see a great example of that in action. So let me tell you exactly why I don't think you're going to be using tuples that often. At the bottom of this file, I'm going to declare a new variable called car specs, like so. And I'm going to assign it some data that has a real important meaning around a car, like some specifications around a car. So I'm going to assign it a tuple of 400, 3354, like so. And I'll make sure that I annotate the type on here to make sure it's really clear that this is a tuple. So it's a number and a number like so. Okay, so here's the question. What do these numbers mean to you? I mean, looking at this line of code right here in isolation, what do those numbers mean? Clearly it has something to do with these specs around a car, but what is the purpose of these numbers? Well, for us as engineers, I don't think that we can really look at this line of code and understand what is going on here. We know that there are two values, we know that they are numbers, but that's pretty much it. So let's try writing out that same type of data structure right here, but instead as an object. So if I write out a very similar variable right here, maybe I'll call it car stats this time, I'm going to make it an object, and because it's an object this time, I have to add in a key and a value. So for the value 400, I'm going to give a key of horsepower. Horsepower, yeah, there we go. And then for the 3354, I'll put in weight, like so. All right, so what am I trying to illustrate here? Well, if we use a tuple to represent some meaningful data, it's really hard for you and I as engineers to look at this value right here and understand what we are trying to say. However, in an object format right here, because we are forced to put in a key, it is immediately obvious what we are working with. I can look at this object right here and understand, oh, horsepower, 400, got it. And then for weight, this is the weight of maybe a car in pounds, 3,354 pounds. So when we make use of an object to model a record, it's really clear what we are working with at one glance. But when we are working with a tuple, much harder to understand exactly what is going on at a glance. So honestly, I think that in general, anytime we want to model a record or record it in our application somehow, we're going to stick with a JavaScript convention of reaching for an object as opposed to a tuple. Now, like I said, there are some corner cases where we might want to use this in some types of applications, and we will see an example of it later on inside this course, actually with one of the first 2 or 3 applications we're going to work on. All right, so I'm sorry to teach you about tuples and then say, hey, we're never going to use them, but nonetheless, it is a feature of TypeScript that is very prominently kind of featured in the official documentation. So I just wanted to make sure you have at least a passing idea of what these tuple things are all about. So let's take a quick pause right here, and we're going to move on to our next topic in the next video. In this video, we're going to start to discuss interfaces in TypeScript. So as usual, we'll get a plain definition, some examples, and so on. As a quick aside here, we're going to spend a pretty good amount of time in TypeScript talking about interfaces. The interplay between interfaces and classes is how we're going to really get very strong code reuse when we are writing TypeScript code. So if you understand interfaces really well, it's going to help you design really excellent applications. As a matter of fact, the entire second half of this course, where we're going to work on a lot of applications, is really going to come down to understanding how we can get interfaces and classes to work together really, really nicely. So if you don't understand this first take through interfaces, totally fine, because we're going to be discussing them quite a bit. All right, so with that in mind, let's take a look at a quick definition here. So when we have interfaces, we are going to write out some amount of code to define a new type inside of our application. The goal of this new type is to describe the different property names and the different property types that that object has. So when we create an interface, we are creating a new type inside of our application just the same way that we have types like string or Boolean or number. We're creating another new type. It's a custom type that you and I are going to define. Now, understanding interfaces is a lot easier when you have some code in front of you, so let's do a quick pause right here, come back in the next video, and start to write out some examples. In this video, we're going to start writing out some code to get a better understanding of how interfaces work. You'll notice I'm back inside my code editor, and inside of my root project directory, I'm going to make a new file called interfaces.ts. All right, so inside of here, we're not going to write out an interface just yet. Instead, I first want to define an object that represents a car. We're then going to write a function that kind of operates on that object, and we'll start to introduce interfaces. So to get started, I'm going to make a variable called old civic, like so. Just so you know, a Civic is a type of car, or like a vehicle of sorts, so it's a Honda Civic. By saying old Civic, I just mean to indicate that we are going to make an object that represents a Civic that was made many years ago. So inside this object, I'm going to add a couple of different properties to describe exactly some things about the Civic. So I'm going to give it a model property. Actually, you know what, let's give it a name instead. That's just a little bit more clear. So this car is going to have a name of Civic. I'll then give it a year that it was built of 2000, and then a broken property to describe whether or not this vehicle still runs. So I'll say it's broken. True. Now that we've put that object together, I want to try creating a function that's going to take in this object and just print out some different properties about it. So I'm going to define a function called printVehicle. Then I'm going to add in a single argument. So we want to call this function with a car. I'm going to refer to this argument as, how about just like vehicle? That makes sense. And then remember, we need to add in a type annotation to describe exactly what properties or what type vehicle is. Right now, if I hover over vehicle, it says that it is of type any. Remember, we want to avoid any types inside of our application. Now we saw how to add in an annotation for an object inside of a function just a moment ago. So we're going to put in the set of curly braces, or excuse me, a colon right there, and then a set of curly braces. And then we'll list out all the different properties that we expect this argument to have, and their different types. So I expect a vehicle to have a name that is a string. And remember, inside this type annotation, to separate different properties, we'll place a set of, or a semicolon like so. I then expect a vehicle to have a year that is a number. I'm going to zoom out for a second so you can see this whole line. And I expect a vehicle to have a broken flag that is going to be a Boolean. Finally, I'm going to add in a type annotation to the return of this function. So right after the argument list, I'll put in a colon. I don't expect this function to return anything, so I'm going to give it a type annotation of void like so. Remember, void means our function returns nothing. All right, I'm going to zoom back in. So now inside of here, we can do our actual implementation. So I'll just do a couple console logs using properties from the vehicle. I'm going to use an ES2015 template string, so I'm going to use some backticks here. And I'll do some things like, let's say, how about name? And I'll do vehicle.name. I'll do another little statement here. I'll do something like year, vehicle.year. And then one more for the broken flag as well. So broken. Oh, typo there. There we go. Vehicle.broken. Cool. So now we should be able to call print vehicle and pass in old civic. Old civic structure is a name that is a string, year that is a number, and broken that is a Boolean. And so that meets the type annotation we just put on that argument right there. So we should be able to pass in old civic and not have any issue. So I'm going to take print vehicle and pass in old civic, and everything looks good to me. Perfect. All right, now I say perfect, but maybe not quite perfect. There's one little issue inside this file right now. So I bet you can guess what it is. This type annotation right here is really long. It's kind of hard to read. And if we had any more properties on this object, the type annotation would become even harder to read. In addition, if we added in more functions that we expected to call with old civic, we would then be duplicating this type annotation for each of those different functions. And so we would have this really long annotation right here duplicated several times throughout this file. So as you might imagine, yeah, that's probably not the best. So let's take a quick pause right here. We're going to come back to the next video and figure out how we can improve this file by using an interface. In the last video, we wrote out a little bit of code, but it's got one little issue. We've got a really long type annotation on this function right here. I think you can easily imagine that if we had several other functions inside this file that all expected to be called with old civic, we would have to repeat this type annotation right here several times over. And that would be a lot of duplicate code. So to fix this, we're going to create an interface inside this file. I'm going to go up to the very top, and I'm going to define an interface by writing out the interface keyword, and then a name for the new type that I am creating. Remember, anytime we create an interface, we are creating a new type. A type in the same way that a number is a type, or a string, or a Boolean, or so on. So I'm going to create an interface called vehicle. Whenever we create an interface, we're always going to use a capital letter on the leading edge of the word. You'll also notice I'm using kind of a generic term right here. So I'm not creating an interface called like civic, or an interface called old civic, or new civic, or anything like that. Instead, I'm creating a very generic name right here to describe what different properties a vehicle might have. So then inside these curly braces, I'm going to list out the different property names that I expect an object that is a vehicle to have, and their different types. So in order to be a vehicle, you must have a name property that is a string. You must have a year property that is a number, and you must have a broken property that is a Boolean like so. So once again, we have now created a new type inside of our application called vehicle. And in order to be a vehicle, you have to have these properties, and they must have these different types. So we can now think of vehicle right here as being kind of like a variable of sorts that refers to a type. So rather than writing out this really long form type annotation right here, I can delete that full annotation and replace it with just vehicle, like so. So what are we saying here by putting this code in? We are now saying that in order to call the print vehicle function, you must pass in an object that meets the specifications provided by the vehicle interface. In other words, to call this function, you must provide an object that has a name that is a string, a year that is a number, and broken that is a Boolean. The old civic object satisfies each of those requirements. It has a name that's a string, year that's a number, and broken that is a Boolean. So we are allowed to pass in old civic to print vehicle. You'll notice that down here where we actually call print vehicle, there is no error and no warning or anything like that. So as soon as we added in this statement, Typescript did a little bit of checking for us. A little process went on behind the scenes. TypeScript took a look at the argument we provided, and it said, okay, we need to look at that old civic object and make sure that it satisfies this interface. We need to make sure that old civic has all the appropriate property names and types. And so behind the scenes, TypeScript looped through all these different properties and made sure that old civic had each of those different property names and the appropriate value for each one. If I change any of these types right here and assign a different type, let's say instead of broken, I'm going to put in like just a 1, like so. As soon as I do that, you'll notice we get an error message down here. So TypeScript is telling us that in order to pass in old civic, we have to have a broken property that is a Boolean. But we have a broken property that is a number, and that's why we're seeing an error. So if I change that 1 back to true, everything works again. Likewise, if I misspell any of the property names inside this object, like let's say is broken instead, now our object can no longer be considered to be a vehicle. Remember, to be a vehicle, we have to have a broken property, but I provided a property that is broken. Because those property names are different, TypeScript will not allow me to pass in old civic into the print vehicle function. And if I hover over that error right there, it's going to tell me very plainly, down towards the bottom of this error right here, it says property broken is not present inside the object I provided, but it is required to be a vehicle. So once again, if I change is broken back over to broken, everything works again. Okay, so this right here is some of the very basic interaction or definition of what an interface is. So let's take a quick pause right here. We're going to come back in the next video and start to expand on this example just a little bit more. In this video, I want to add in a couple little notes around syntax of interfaces. So once again, when we define an interface, we're going to list out all the different property names and types that we expect something that is a vehicle to have. We are not only limited to expressing primitive values inside of here. We can instead express any different type we want to inside of an interface. So for example, let's say instead of the year property being a number, we instead want this to be a more complex object, like an instance of a date. To do so, I'm going to replace number with simply date like so. Now, in order for old civic to be considered to be a vehicle, you'll notice that we've got an error down here. We have to update its definition. So instead of year being a simple number, I'm going to instead assign it an instance of a date like so. As soon as I do so, that error down here goes away. So once again, we are not limited to just basic values or primitive values inside of an interface definition. We can assign any type inside there that we want. That also includes functions. So let's say that we want to say that in order for old civic to be considered to be a vehicle, we want it to also have a function called summary. So in other words, I want this object right here to have a property or a function called summary, and if we call it, maybe it should return a string that summarizes some different facts about the vehicle. To express that, I'm going to add in another property on vehicle called summary like so. And then instead of immediately putting in a set or a comma or a colon right there, I'll put in a set of parentheses and then a colon right after it. And I'm going to label what I would expect the summary function to return. So in this case, maybe it's going to return a string that summarizes some different facts about the car. So this right here says that anything that wants to be a vehicle has to have a function called summary that returns a string. If we then go back down to the bottom again, you'll notice we have an error down here as well. So now it says that we do not have a summary property inside of old civic. So to fix this up, we would have to add in a summary function that satisfies this type right here. So it has to be a function with no arguments that returns a string. And so we can add it on like so. So now to return some information about this vehicle, we could return about name is this dot name like so. And again, notice the ES 2015 template string here, so I am using backticks. So now that my object has a summary function that returns a string, it once again qualifies as being a vehicle. So if I go back down to the bottom of the file again, that error has now gone away. And now inside of my print vehicle function, rather than trying to pull off all these different properties one by one, I can instead rely upon that summary function. So I can call something like console.log vehicle.summary, like so. Cool. All right, so again, just two notes here. First off, we can use any type inside of our interface definition we want. We are not limited just to primitive values. Second important note is that inside of our interface definition, we can express functions inside there as well. So let's take a quick pause right here. In the next video, I want to share two more important notes with you around basic syntax of interfaces. So quick pause and I'll see you in just a minute. In this video, I want to go over two more pieces of syntax around interfaces. So to get started, I'm going to go down to the print vehicle function. Inside of here, you'll notice that our implementation now only accesses one property on the vehicle argument. The only thing we are referencing is the summary property. So I got a question for you. We are saying that the argument must be a vehicle. It must satisfy this interface is the terminology we would use. And we've said earlier that the vehicle must have a name, a year, broken, and the summary function. However, our function down here is now only accessing the summary property. So here's the question. Is it important for us to say that a vehicle must have these properties available? I don't think it really is. So what happens if I delete those additional properties? I can delete them, they go away, and now you'll notice I do not see any errors inside my file. Why is that? Well, when I call print vehicle right here, we are saying that in order to be passed into this function, you must satisfy the vehicle interface. So we pass in old Civic, and Typescript behind the scenes does a quick check for us. It says, does this object right here satisfy the vehicle interface? So Typescript is going to go back to the vehicle interface definition, and it says, in order to be considered to be a vehicle, you must have a function called summary that returns a string. It then looks at the old Civic object, and it says, okay, does this object have a summary property that is a function that returns a string? Yes, it does. And that's the only question that gets asked. It doesn't matter if we have additional properties on old Civic. It doesn't matter. When Typescript tries to decide if old Civic is a vehicle or not, it's not going to say, oh, you've got these extra properties. Sorry, you can't be a vehicle. It's only going to check to see if it has this list of properties right here. If it has that list, awesome. It is qualified to be a vehicle. So the code we have here still works, but we've got a much more condensed interface definition. So here's the important thing here. Something I want to point out as like kind of step 2 of this little refactor. Now that our interface only has a single function definition in it, do you think the name vehicle is really appropriate here? Like, is calling an object that has a summary property that is a function that returns a string, does it really seem appropriate to call that a vehicle? I would say maybe it doesn't. Maybe a more appropriate interface or a name for this interface would now be something like, I don't know, reportable or something like that. So now we're saying that in order to be considered the type reportable, you must have a function called summary that returns a string. And so now to fix up our file here, down here inside of print vehicles, there is no more vehicle type, so I'm going to replace that with reportable. Now just to be clear, the word reportable, I'm kind of meaning to say something that is reportable has a summary function that returns a string. So this is like something that can be reported. All right, so notice how our definition for the interface is now a lot shorter and a little bit more generic than it was before. So now back down inside the print vehicle interface or function down here, I want to just point out one more thing here. Notice how we've got a function called print vehicle. It takes an argument called vehicle and it refers to that function or that argument inside the function. But once again, I got a question for you. Does anything about this function now really seem like it has anything to do with vehicles? I don't think it really does. The only thing that this function really does is take in something that can be reported on and then console log a summary about that thing. So maybe we should update some of the terminology inside this function. Maybe instead of an argument called vehicle, we call this something that's called like, I don't know, report, or how about like item? Maybe that makes sense. And then inside, or rather than calling this thing print vehicle, I want to call it maybe something a little bit more appropriate, like print summary or something like that. And I'm going to update the reference down here as well to be simply print summary. Okay, so all we've really done here is kind of pointed out how our interface no longer really has anything to do specifically with vehicles. And so I just decided to rename it into something a little bit more generic. And I did the same thing with the function down here. So let's take a quick pause right here. We're going to come back in the next video and we're going to discuss why this was a very significant refactor by adding in just a little bit more code. So quick pause and I'll see you in just a minute. In the last video, we refactored our interface to have a little bit more generic name, and we did the same thing with our function down here. So now I want to do something kind of interesting inside this file. Right now we've got an object called old civic. I want to define another new object right underneath it. And I'm going to call this something like drink. Remember just a couple of videos ago we did some examples on drinks, and we said that a drink had like a color and carbonated and some other thing like that. Let's try expressing a drink object right here with some of those same properties. So I'm going to maybe give this thing a color that is brown, and maybe carbonated, and that'll be a Boolean true. And then maybe it will also have like that sugar content. And that's really supposed to be like number in grams, so like 40 grams of sugar. And then I'm going to give this one more property. I'm going to give it a summary property. Summary is going to be a function. Anytime we call it, it's going to return a string. And so inside of here, I'm going to return something like my drink is, or how about has, and then this dot sugar, grams of sugar. And that's reasonable. Once again, notice that I'm using backticks here to form up this string. All right, so here's what gets really interesting. Here's like the entire point of interfaces. If you don't get this quite right away, I'm going to show you a couple diagrams to really help you understand what's going on. But here's what's going on. Notice how our old civic function has a summary function tied to it. Or excuse me, old civic object has a summary function tied to it. Our drink object also has a summary function tied to it. These two objects right here represent very different things inside of our application, but they both have a summary function that returns a string. That means that they are both considered to be reportable types. So because they both have a property called summary that is a function that returns a string, this is of type reportable, and this is of type reportable. Because they are both of type reportable, we can use both old civic and drink with the function we defined down here. So I can call print summary with old civic. I can also call print summary with drink as well. And it works equally well with both of these very different objects. So what's the big point here? The point is that we can use a single interface to describe the shape or the different properties of very different objects. When we do so, we can have those objects implement different properties or different functions. And by doing so, we can make these very different objects interact with different functions that we create, like print summary right here. So this encourages us to write somewhat generic-looking functions. Notice how this is now print summary. Would it have made sense to have this be like print vehicle and then pass in drink to it? No, I don't think so. That would have not made a lot of sense. So instead, we decided to make a somewhat generic-looking interface that described what we had to do in order to call this function right here. I'm going to change that back to print summary, by the way. So in doing so, we've now got a much more reusable function inside of our application. This function can be used with any type of object that satisfies the reportable interface. And this feature, this right here, is what is going to encourage us to write more reusable code with TypeScript. Now I know this is like a super basic example and it's very contrived, but I just want this to be your first taste of how we're going to use interfaces in general. Now, to make sure everything is super crystal clear here, let's take a quick pause. In the next video, we're going to kind of reiterate what we did and what the entire point of this application was. We're going to take a look at a couple different diagrams to help you understand what's going on. And we'll move on to our next subject, where we're going to very quickly continue to see what the power of interfaces is inside of our applications. So quick pause, and I'll see you in just a minute. In this video, I want to show you a couple different diagrams to help you really understand what is going on inside this file and really understand what the goal of the interface is right here. So let's get to it. All right, on the left-hand side at the very bottom, we've got that print summary function that we just put together. We can kind of think of that interface that we are using to annotate the argument to that function as being like a gatekeeper of sorts. In other words, if we ever have any value inside of our application, like say old civic or drink over here, and we want to use these values with the print summary function, we have to make sure that those values implement the reportable interface. In other words, these two values have to have a summary function that returns a string. If they don't, then they cannot be used with print summary. This mechanic right here of using an interface for gatekeeping is going to be one of the prime ways that we get some amount of code reuse inside of TypeScript. And you're going to see this strategy used over and over in every application we put together in this course. So the general strategy that we're going to use for code reuse in TypeScript is to create functions that accept arguments that are typed with interfaces. So all the different functions we're going to create are going to accept interfaces as much as possible. Obviously, not every last function we ever put together is always going to require an interface type argument. Sometimes we're going to have something that takes a string or a Boolean, or maybe a plain object in some far-off cases. But in general, we're going to try to create functions that accept arguments that are typed with interfaces. And then in order to call those functions, we're going to make sure that we have objects or classes that can decide to implement that interface. So it's essentially this same scenario right over here. We created a function that takes an interface type as an argument. So other values inside of our application can opt into satisfying or implementing that interface to work with that function. This diagram that you're seeing right here, we can kind of generalize into something like this. So we can imagine some like arbitrary interface over here that's going to govern access to some function. And if we want to work with this function, any other object must implement that interface. So we're going to see this exact diagram right here in many other applications we work on. And every single time, it's going to have the exact same meaning. We're going to talk about how we've got some function, and in order to call it, we must have some values that implement the given interface that's acting as the gatekeeper. All right, so at this point, I'm sure this is still a little bit confusing, but like I said earlier, the good news is that the entire course, like every application we put together, is going to be focusing 100% on this mechanic. We're going to be focusing on how to define different interfaces to restrict access to different functions, and then decide how to implement those different interfaces in different objects that we're going to create. So the real code reuse we're going to get here is making essentially this function right here really reusable. As long as a value implements that interface, it can work with this function. All right, so let's take a quick pause right here. We're going to move on to our next topic in the next video.